All right, we should be live. Let me just double check that all of the things are where they should be. Welcome, welcome everybody. Oh, let's send out the announcement. This should be here. This should be here-ish. And I should probably move this around to like here. There we go. Welcome, welcome. Howdy, howdy. How am I? I'm doing A-okay. A-okay. How am I? I'm doing A-okay. Oh, A-okay. Got some audio there. Oops. Oopsie poopsie. You're still waiting to see what's on the bottom of Flat Earth? Yeah, so the bottom of Flat Earth is probably, my guess is hell. That's like what it's gotta be, right? Under Sheol are the pillars of Earth. Yeah, so the pillars are standing on turtles, and the turtles, no, the pillars are standing on elephants, and the elephants are standing on a one big turtle that swims through the sky, right? Welcome, welcome. Yeah, Flat Earth is a good meme. Oh, my cat was like very evil today. The turtle doesn't need to stand on anything because turtles can swim. True. What brand is my microwave? I don't know. Are people actually still flat earthers? Yeah, but it seems like they're a slowly dying breed. At least they're kind of like self-insulating now. They don't really go out and talk to people anymore. I think your audio is a little low on YouTube. Is it? Are you sure? I work with a guy who believes in flat earth. Yeah, there are more of them than you think, but like they keep it secret because it's embarrassing. Oh. We actually have a flat earther in the TikTok chat. His name is Luke Flatwalker. But I think that he's probably too embarrassed to join up and actually defend his silly worldview. So he'll probably just stay in the comments. Embarrassing is believing you're upside down. Oh, we have two flat earthers in the TikTok comments. Poor Blitz having to talk for me. Well, I wouldn't have to talk for you if you came up yourself. He's in the guest box. Great. One sec. Pull him up. Just gotta...
What's up, dude?
Lucas. Should I call you Lucas? Luke? What do you prefer?
Luke Flatwalker.
Luke Flatwalker. Great. How's it going?
I'm doing good. So why is there no curve?
So why is there is a curve?
No, there's not.
I mean, you say there's not, but like you can see
We're
it in
gonna
pictures.
put me on the big screen.
Sorry?
Put me on the big screen.
I can't put you on the big screen. People are watching you on several different platforms.
You're a chicken.
It's not a thing I can do. But what are we looking at?
A 3D model of a globe Earth model. And we're going to compare it with reality because I took a photo at 35,000 feet. Have you been at 35,000 feet?
I have been.
Awesome. Did you see it out the window?
I usually sit in the aisle.
Oh, okay. Yeah, that's always the typical Glober response. So you didn't look out the window.
I'm very tall. I've looked out the windows before.
So you didn't look out the window. Okay.
I've looked out the windows before on an airplane.
Okay, cool. Did you see any left to right curvature whatsoever?
So the human eye is not really sensitive enough to see that.
No,
So you
your
wouldn't
eyes
expect to
are.
see
Your
it.
eyes are, you idiot.
Are they?
You can measure it, you can see it. So did you see the
we are
left to right
We're
curvature?
coming in awfully hot here. Why do you say that our
so-
eyes are sensitive enough?
All right. So you can't answer my question. Did you see the left to right curve?
I already told you no. And
Thank
I gave you the
Welcome to
explanation as to
Flat Earth,
why.
guys. Have a good one.
Oh, are you crashing out already? Oh, we crashed out already. That was fast. Yeah, so just for everybody who wants to actually know what's going on, the claim is that if let me take this off. The claim is that if you can't see curvature, then it can't be flat, or then it can't be round, right? Now, that would be great if it were the case that our eyes were sensitive enough to see the curvature. But our eyes just aren't really that good, right? Especially my eyes. I have some pretty thick glasses. However, what you can do is you can actually just use equipment instead. The equipment can be better than our eyes, so we can do that. So instead, what we can do is we can pull up a scientific paper that's done the analysis. So here, I'll show you guys this. It's an interesting paper. Pull it up. This is a paper by David K. Lynch. And basically, he asked the question, look, should we be able to detect the curvature of the horizon from a plane? Now, he's an optometrist, or an optic whatever. This is published in an optics journal. And he's like, yeah, so human eyes probably can't, but cameras probably can. So he's using a camera with a lens. Now, the lens is going to have distortion. If the horizon is in the top half of the lens, you'll see barrel distortion this way. If it's in the middle of the lens, you'll see no barrel distortion. If it's in the bottom half of the lens, you'll see barrel distortion in the other direction. So these pictures were taken very close together, horizon placed at the top, center, and bottom of the frame respectively. Fine. So he knows with this camera, if there's no curvature, and you put it, or rather, if you see curvature while the horizon is in the middle of the frame, then that means it's genuine curvature. It's not distortion. So what did he do? He went up into a plane. Oh, and by the way, here's the same thing. He just did a compression. He just did horizontal compression. And so you can see that the barrel distortion is present. So he went up into a plane at 35,000 feet, and he just took a picture. And this is the picture that he took. He placed the horizon in the center. And what do you know? So here's the left edge of the horizon over here. He drew a line. Here's the right edge of the horizon over here. Straight line in paint. And then here's the middle of the horizon. Notice that it's slightly above, which means that there's a slight bowing of the horizon. Now, this is a scientific paper. You can actually see the slight, it's kind of hard to see actually. I can see it on my computer, but you guys might not be able to see it. You can actually see the slight distinction between the sky and where the horizon is here. But he actually didn't just rely on eyeballing where the horizon was. He actually did a color analysis to be able to locate the horizon based off of color gradients. And it turns out the amount of curvature that he detected in this particular photo is exactly consistent. Here's where the data is. This is the vertical angle here, and this is the horizontal angle from the center of the limb, so that's how much it curved. That's exactly consistent with being like roughly 7 miles up, which is 35,000 feet-ish, which is exactly how high a plane flies. So not only did he measure curvature, he measured curvature in exactly the amount that you would expect as seen from a plane. So, I mean, it's just the case that you can detect and see curvature with instruments. It's just hard to do with your eyes because your eyes aren't perfect. Anyway, I felt like that probably was owed an explanation because Luke came in real hot and decided to, run before he could see the conflicting evidence. But now you've seen it. Anyway, let's bring up our next guest. We have somebody who's supposed to be joining the guest box. Their name is Lane. I don't know if they're actually going to come up, though. We shall see. All right, it looks like Lane's not connecting. Let's talk to science and natural law. This person is got to be interested in science. Science and natural law, how's it going?
Yeah, how's it going?
Sorry, just writing down your name. What shape do you think the Earth is?
Flat.
Why so?
Well, that's what we observe and measure.
So, were you here for the last 5 minutes?
I just came up just now. I just was strolling in there. But you heard my answer, right? You said why so? I'm saying like we observe the Earth flat and we measure it flat with angles.
Yeah. So like 5 minutes ago, or the last 5 minutes, like really it ended about 1 minute ago, I actually went over an observation of the shape of the Earth. Although I think that people are saying in the comments that you've been here, so you definitely heard the explanation. So what do you make of the detection of curvature from a photograph from 35,000 feet from an airplane?
I don't know. I have plenty of weather balloons, videos of the horizon being, and the horizon is not Earth curve. It's an optical phenomenon.
Right,
where
but so if the Earth was curved, you would expect the horizon to have a left-right curvature to a small degree, depending on your altitude. If the Earth was not curved, you would not expect it to have a left-right curvature.
I don't know what it would like if it was curved, because we measure the distance to the horizon.
So the mathematics says that the curvature should appear to be left. There should be some amount of left-right curvature if the Earth were a sphere. That's what the mathematics says.
Yeah, but while I'm even thinking about Earth having a curve, when I don't have a geometric horizon or a Earth curve to observe in the first place, all I observe is flatness, and I'm measuring the Earth flat with angles. For example, for your height of eye to the horizon, you're measuring the Earth flat
for your height of eye to the horizon. I don't follow. So what measurements have you done?
Well, when you measure the distance to the horizon, right? Your height of eye is part of
science and natural law. Is this sea level?
No.
I promise.
Anyway, for your height, for your height of eye, right? The distance to the horizon. When we measure the distance to the horizon, your height of eye is part of that measurement, right?
Yeah.
1.2 times square root. Okay, and we measure the Earth flat for that.
What do you mean we measure the Earth flat to that? The distance to the horizon is determined using spherical geometry.
Eye level and surface level, two straight lines.
Eye level and surface level, they're not two straight lines. That's why there's a horizon at all. So look, how do you think the calculation to determine how far away the horizon appears to be is done?
Which horizon? Okay, which horizon?
The thing that you see, where the sky meets the ground.
Okay, so we're not talking about Earth curve then.
How do you think that calculation is done?
Hold on, no. When we say the horizon, we're not talking about the distance to a geometric.
Can you answer my question, please?
You say how, what?
Can you answer my question, please?
What's your question?
How do you think that calculation is done to figure out the distance to the horizon, like, from your eyeballs?
How is it done? We establish level, right? And we measure we measure the height of the observer and how far the horizon will be. Yeah. So based on that.
Look, okay. Do you understand that there's a formula that tells you if you are 4 feet tall, we love our short kings here. If you're 4 feet tall, then the horizon is X miles away. Do you understand that there's a formula that gives you that from the input gives you an output? Yeah. Okay.
But those are flat Earth measurements.
Are they? So how does that calculation work? Are you familiar with how it works?
Okay. For your height, right? The observer height, right? Let's say 6 feet. 6 feet in respect to what?
We love our short kings. Respect to what? With
6 feet in respect to what?
With respect to your ground, or to the ground, to like your feet.
To the surface level, plane of reference.
No, it doesn't require a plane of reference to figure out how tall you are. You just need to know the distance between your feet and your head.
When we measure a mountain, we measure it in respect to a plane of reference. When you measure your height of eye
the reason you do that is because you're trying to. The reason you do that is because you're trying to find distance above sea level. right? If you want to know how
Yeah,
tall
which
you
is
are, you don't
what-
need to know your height above sea level.
We're
You
not
just
talking
need to know
about the
how.
hydro.
You just need a ruler, and then you can stack them up next to your feet.
Yeah, and that which is gonna give you two straight line, right? You're gonna be parallel to surface level.
What? No,
Your eye
there's
level,
one line,
your,
right? There's
hold
one
on.
line connecting your
eye-
feet to your
okay,
head.
Is your eye level in the math, right? Is your
Mhm.
eye level in surface level parallel? Yes or no?
No, they're not.
Oh, so you're measuring your height to the distance to the horizon from a curved surface.
Yeah,
Oh, okay, well, if that's what you think, then
That's
you
where-
wrong. And
that's where the formula
that's
comes
what you need to
from.
be corrected about. That-
So
that's
do you know what the formula
Which
is?
one comes first? Which comes from first, the measurement
Do
or
you
the
know which
formula?
formula comes first?
Hold on. Here's what I'm
Do you know
saying
where
though.
the formula comes from?
Okay, which comes first, the measurement or the formula?
Historically, I don't know.
Yeah, well, the measurement, you measuring when you measuring the distance between the observer and the horizon.
How do you measure the distance between the observer and the horizon?
You say, how do you measure it?
Yeah.
You can think, how do they measure it? They take 1.2 times the square root of the observer. Well, the distance to the horizon, we measure the distance to the horizon from in respect to the observer height.
Yeah, how do you do that?
I don't remember the whole thing. Why?
Well, it sounds like you're saying that that's definitely what was done first, but it seems like that you don't actually know.
I'm sure the measurement comes before the formula. You got to take a measurement.
How can you be sure of that if you don't know?
Well, okay, I know this for Alberoni to give you the height of the mountain. He first measured the earth flat to give you well, for him to give you the drop, for him to give you the
Didn't Alberoni
drop.
know that the Earth was a globe?
Okay, we talk about what he measured. Okay, what did Alberoni measure before he
Yeah,
go on top of the mountain?
he measured the circumference of the Earth.
No.
Sorry,
Okay,
he
listen,
estimated the circumference of the Earth. I'm sorry.
That wasn't my question. My question is,
He didn't measure the Earth flat. That's not a thing that he did.
Okay. Yes. Okay. So you just because you don't have that knowledge, it's not your fault, right? Before for him to,
Can you give me evidence that he measured the Earth flat?
He measured. Hold on. He measured the Earth flat when.
Can you give me evidence that that's true?
I will. Hold on. He measured the Earth flat to give you the height of the mountain that you're gonna go on top of.
Okay, so where's the evidence that he did this? That he measured the Earth flat?
When he gave you for the height of the mountain, he took an elevation
angle. Where's the evidence that he measured the Earth flat? So elevation angles work on a globe Earth just as well. Elevation angles work just as well on a globe.
Okay, you're not measuring an elevation angle from a curved surface.
Sure, you can.
That's not what he did. He didn't measure. He did
How
not
do you
measure.
know?
He did not take because that's not what that's not what he did.
How do you
That's
know?
what you have a citation that says that's what he did? Because I don't know elevation angles to be taken from a curved surface. So that's why.
Wait, so you don't understand how elevation angles can be taken from a curved surface?
No, you do not take an elevation angle
You sure
from
can.
a curved surface.
You sure can.
No, you cannot. Well, I'm telling you, you cannot.
Let me draw you a picture. You want a diagram?
I don't need
I can draw a diagram.
No. I want a citation. No. I want a citation
Wait,
from a mathematician.
I'm sorry. You said that you can't take an elevation angle from a curved surface.
You cannot.
I'll show you
No,
that you can.
do not.
I'll show you that you can. I'll draw you a
I'm
picture.
not saying. Okay. I'll look at the picture, but can you give me a citation from a mathematician?
I'm a mathematician.
No, not from you. You're gonna. Why would
I'm a
I take a
mathematician.
citation from you? No, I want a source from
I'm a source.
Harvard. No, you cannot tell me where you you the one that I'm talking to, and I'm saying like you wrong, and then you saying you are the authority, you are the expert.
Well,
no,
I mean, in
you're
some
not.
sense, I am. I mean, I am. That's why I do
you
this.
can believe. You can believe what you want to
okay,
believe.
so here's a curved surface. We agree that this is a curved surface, right? All right. Let's. I'm a little red dot. Let's pretend that that's my head. Let's make me a little bit lower. There. So that's my head, right? And then I'm gonna draw like a little mountain. Like this is obviously not the scale, but it would be hard to make it to scale in a drawing. So let's say that this is a mountain, right? Right. So I can look at my local, let me make this narrower. I can look at my local horizontal by dropping a vertical. So I drop a vertical first. Something like this. I want to make it so then it's right. Drop a vertical, and then that will give me a perpendicular. perpendicular is like this. Let me draw it in a different color. Orange, how about? Something like, just want to get the angle right. Something like this. Probably not perfect. So if I wanted to measure an elevation angle, what I would do is I would go and I would measure, obviously not the scale, I would measure this angle to the top of the mountain. And it would be, the elevation angle would be that angle there between the orange line and the blue line. That would be the elevation, and it makes perfect sense on a curved surface.
That you saying that's what Alberoni did?
If he measured an elevation angle, which, you know, plausibly he did.
So you don't even know.
Well, no, I mean, like, you know, I'm believing you when you say that he measured an elevation angle. He also measured these. He also. Please, I'm in the middle of it. I'm gonna have to mute you. So look, you said that he measured an elevation angle of a mountain. I believe you. Now, he also measured the circumference of the Earth, which means that he knew that the Earth was curved. And if he measured, if he measured an elevation angle. If he measured an elevation angle, then it must have been on a curved surface because he knew that the Earth was a globe.
But that's not what happens, though.
What do you mean that's not what happens? I just showed you how it can work.
You're saying if that was the case.
So do we agree that you can measure elevation angles on a curved surface?
No, you do not take an elevation angle from a curved surface.
Okay, so which part of the diagram confused you?
Your diagram doesn't mean you take an elevation angle from a curved surface.
Do we agree that you can take an elevation angle from a curved surface?
No, you cannot take an elevation angle.
So which part of the diagram confused you?
Nothing confused me. You're not taking it from a curved surface.
This diagram shows you how to take an elevation angle while on a curved surface. Do we agree that this is a thing that you can do?
Hold on. And it's a red herring
I don't
because
think you know what that word means.
It don't relate to what I'm. It's having nothing to do with what I'm saying because Alberoni. That's not my argument. The red herring is not. That's not my argument because my argument is Alberoni took an elevation angle from a horizontal plane, not a curved surface. That's how he took it. He didn't show no curved surface. He didn't.
We can agree that he took an elevation angle, right?
And which is. Okay.
Can we agree that he took an elevation angle?
I bring the definition of an elevation angle.
Can we agree that he took an elevation angle?
Yeah, and I bring you the definition.
So we agree that he took an elevation angle. Now, do we also agree that this diagram illustrates how you can take an elevation angle while on a curved surface?
Not from a curved surface.
This person, the red dot, is standing on a curved surface.
Uh-huh. And the
thing that they're measuring the elevation angle to is also on the curved surface.
Okay, you're begging the question.
So do we agree that it is possible to measure an elevation angle while standing on a curved surface?
That's not, you're changing the argument. You're saying you can get an elevation angle.
I'm not changing the argument. I'm telling you that you can measure an elevation angle from a curved surface.
Here's what I'm saying.
Nothing has changed.
My argument is you cannot take an elevation angle from a curved surface.
What do you think this diagram is depicting?
Oh my God! Listen, I don't know what
do you think this diagram is. So which part is it? Which part of it is confusing for you? What part of it is confusing for you? I can explain it.
Okay, listen.
Which part is confusing? I'm happy to explain it.
Can we establish what you're arguing about right now, right? Okay.
Sure.
The argument is this. You say you can take an elevation angle from a curved surface, right?
Mm-hmm. Yeah, like in this diagram.
I say you do not take an elevation angle from a curved surface. And I can give you the definition of an elevation angle.
I mean, you could give me the definition if you want. I'm asking you, do you understand what's going on in this? Do you understand what's going on in this diagram?
You making up something that is not the case.
Do you understand what's going on in this diagram?
Yeah. You relating something. You begging the question.
So can you explain what the issue is?
The issue is
that's not what happens in reality. Taking an elevation angle.
Oh my God. I'm telling you what the issue is.
You're just begging the question. You're assuming that that's not what happens in the reality because you're assuming that the Earth is flat.
No, I don't. That's not what I don't do that. I'm not begging the question. That's how we take elevation angle. We have the definition.
So I just Googled elevation angle definition. The angle of elevation is the angle formed between a horizontal line and the line of sight to an object that is above the horizontal line. Now let's go look at my diagram. Exactly. We have a horizontal line in orange, and we have the line of sight in blue. So it's the angle between the orange horizontal line and the blue line of sight.
So not from the curve. So to the curve,
no,
not
but
from the curve.
This is what it. Okay, so is this a semantics issue
Okay,
then?
to the,
Like we agree that
listen,
you can take
to
an
the
out.
curve, not
We
to the
agree.
curve, not from the curve.
So we agree that you can take an elevation angle while standing on a curved surface, right?
But that's not the argument. The argument
That
is
is
you
the
cannot.
argument. What are you talking
Okay,
about?
can I say
That
it?
was the whole
All right, well, let me tell
conversation.
you. Okay, yeah, I'll tell you again since you can't keep
Okay,
up.
sure.
You cannot get
Sure.
an elevation angle from a curved surface. Your
What do
diagram
you,
is not
so
depicting an
sure it is.
elevation
This
angle
guy
from
is
a curved
this guy is on a curved surface, so he is taking an elevation angle from a curved surface.
No,
The location that he is in is a curved surface.
He's taking
If
it
this
from
is a semantic, if you're having a semantic look,
not
science,
from a curved
science
surface.
and natural law. If this is a semantic issue, if you just don't like the word that I used,
It's
fine.
not
But the
semantic.
point is, I mean, it really is. But the point is
It's
that
not.
there's no issue
The
taking an elevation
definition-
angle while standing on a curved surface. Do we agree on that?
Okay, the definition, my definition matches what I'm saying compared to yours.
Do we agree that there's no issue with taking an elevation angle while you are standing on a curved surface?
Okay, that was not the argument. The
Okay,
argument is
that is the argument
Listen,
because that's
No,
why you
I'ma
brought
show
up
you why.
Al-Biruni in the first place.
Can I tell you why? That's not the argument. You're not representing the argument correctly. Let me represent the
Okay, so why'd you bring
What
up
I
Al-Biruni in the first place?
because I'm showing how he
Answer the
measured the
question,
earth flat.
please. Okay, explain to me
measure- how you measure-
how taking an angle of elevation shows the Earth is flat.
It's in the definition.
No, it's not.
Can you want me to read the definition for you?
We just went over what the definition is. The angle of
And-
elevation is
okay,
the angle formed
it's
between
the
a horizontal
horizontal
line and the
plane
line
the
of sight to an
observer
object that
standing
is
on.
above the horizontal line. We just went over that.
The horizontal
We have
plane
two
the
hor-
observer is standing on.
No, it doesn't say that.
Okay, I'll show you one that says that.
Okay, sure. We can probably get rid of the diagram now. We probably don't need it anymore. Oh, wait.
Give me a second, I'll give you one.
Sure. We can even go look at Merriam-Webster. The angle formed by the line of sight and the horizontal plane for an object above the horizontal. So yeah, I mean, right. So if the diagram that I drew was three-dimensional, this orange thing would be a two-dimensional horizontal plane that's tangent to the surface. It's just a two-dimensional picture instead of a three-dimensional picture, so it's a line instead of a plane.
It shows you don't know what you're talking about. You cannot take an elevation angle from a curved surface. Every definition you
clear.
read is
No. I mean,
horizontal.
like, this diagram shows exactly what we're talking about. It's perfectly in line with the definitions. And it shows a person standing on a curved surface taking an elevation angle. Now, it seems like you have trouble with that. Can I ask you a question, science and natural law?
That's not the argument, though. That's not the argument. You keep switching the argument.
Right. So it turns out that you don't actually need to be standing on a horizontal plane in order to take an angle of elevation. Do we agree with that?
Well, you taking the elevation angle from where? From a horizontal plane. That's my
No,
point.
you don't have to. You don't have to be standing on a horizontal plane in order to take an elevation
According
angle.
to the definition.
No,
According to the definition,
where in the
it's saying
definition-
that.
Where in the definition does it say standing on a horizontal plane?
Okay, I'll read it for you. You want me to read it?
Go for it. By the way, $2 says that he adds the word while standing on it somewhere in the definition.
$2. I'm not adding it. This is what it says verbatim,
Okay.
like word for word.
Yeah. So I'm going. By the way,
think you're
read your
good. I
definition,
think
and
you're
then
good.
we'll talk about where the definition came from. But go ahead.
What should be where it come from?
Well, go ahead. Read your definition first. Read your definition.
Okay. All right, let me look for it real quick. Give me a second. Damn, I have a problem using this thing. Oh. Give me a second.
This is real rough. So I mean, the definitions I pulled one definition from the AI overview, the other one I pulled from Merriam-Webster. So, and they both agree with the diagram that I've drawn.
No, they agree with me.
So where's the definition that agrees with you?
The definition plus the one I'm about to present you.
Yeah, please go ahead and present me with the definition that says that you have to be standing on a horizontal surface.
I'm saying the definition does imply. It says that. It says that.
No, it doesn't say anything about where you have to be standing.
Okay, hold on. Why is it? I'm having problem with this thing right here.
I believe it. Big yawn.
Oh, God. Give me a second.
We've given you sex. That came out wrong. We've given you multiple seconds.
I'm not using the device that I normally use. I'm having.
Phrasing? Yeah, tell me about it. Oops, y'all. Look. So many seconds.
All right, I got it.
Okay.
I got it.
Yeah. Read us the definition.
Definition. From sustainable by design.
From sustainable by design, okay.
Yeah. The altitude angle, sometimes referred to as the solar elevation angle, describes how high the sun appears in the sky. The angle is measured between an imaginary line between the observer and the sun in the horizontal plane the observer is standing on.
Yeah, that's a crazy definition. Why didn't you go to a dictionary?
What's wrong with that? What's wrong with that definition?
It's wrong.
Your definition
Yeah,
said the same thing.
I used Merriam-Webster, my guy.
And it said the same thing.
No, the thing that you said is that the guy is standing on it.
Read it again.
Yeah, yours says that like something about the horizontal plane the observer is standing on.
Yeah,
the definition that I've given, which is from Merriam-Webster, is
it's the same thing.
No, I'll just show you what it is.
It just don't tell you where the observer is standing, but it's
right. That's the important part. So here's Merriam-Webster.
The observer is standing on Earth anyway.
The angle formed by the line of sight and the horizontal plane for an object above the horizontal. So it says nothing about where the observer is standing.
Listen, the object is above what?
The horizontal referring to the horizontal plane.
Exactly. Where is the observer standing? Where is the observer standing?
The angle of elevation says nothing about where the observer is standing, and it's
Hold
unrelated.
on, I'm asking you. Where do you think the observer is standing?
On the Earth, usually.
Exactly.
The Earth's not a plane, though.
Above the Earth is what?
No, it doesn't say above the Earth. It says above the horizontal.
No. Listen, I'm asking you. What's above the Earth the observer is observing?
Wait, what's above the Earth the observer is observing? I don't know what that question means.
Yeah. Okay, I'll read it again. The altitude angle, right? Because the observer, what's above.
So here we have Merriam-Webster.
What's above the horizontal plane is the object, the sun.
Yeah, the object is above the horizontal plane.
Okay,
yeah.
And the horizon, and the observer is standing on the ground.
Yep.
Below the
observer is standing on the ground.
Plane, the object is the altitude angle.
The observer is standing on the ground.
Listen, yeah. So that's where the object is below the horizontal plane the observer is standing on. The
observer is not standing below the horizontal plane. The observer is not standing on the horizontal plane. It's not standing below the horizontal plane. I think you're confused.
No.
Do you want me to show you the diagram again?
No, I'll show you the diagram and show you what I mean.
List mode. One sec. Here's the diagram again. So in orange, we have the horizontal plane. In blue, we have the angle above the horizontal plane. And in black, we have the curvature of the Earth that the observer is standing on.
What about mine? What is mine showing?
I can't see yours.
You blocked it, or it went out? It just went out. It was up there. I don't know how you didn't see it.
I wasn't looking at your screen.
The observer.
So just to be clear,
what is that? Hold on. What is that? Is that showing the same thing you're showing?
No, that's showing like this weird flat Earth thing. Let me show you the. Let me show the guests what the.
The person that wrote this is not a flat Earth.
Are you sure?
What are you talking about?
Are you sure, man? Because that's a pretty sus definition. It has nothing to do with flat Earth. So what did you have to type in order to find something that perfectly agreed with your definition instead of just using a regular dictionary?
It agree with yours as well.
No, it doesn't. No, they're different.
Plane for both.
So look, do you agree that given this definition,
is on the surface.
do you agree that you can measure angles of elevation while standing on a curved surface? Yes or no?
That's not what's going on, though.
Do you agree that you can do it? Yes or no?
Not from a curved surface.
Do you agree that you can measure an angle of elevation while standing on a curved surface? Yes or no?
Yes, you can.
Okay, great. Then that's what Al Bruni could have done.
But
So
that's
we
not what
agree.
he did.
Okay,
He
so
did not
now you have
measure
to
an
now you have to make the
elevation
distinction. How do you know that that's not what he did?
Because that's not. It's in the definition of for an elevation angle.
We just agreed
It's
that
a
you can
hard-
measure an elevation
What
angle
about-
while standing
listen.
on a curved
Okay, let me ask
surface.
you this. Let me ask
We
you
just
this.
agreed.
When you take, listen.
I don't know
When
why you
take-
already conceded and now you're backtracking.
Listen. When you take an elevation angle, right?
Yeah.
What is part of that measurement? Part of that measurement is the horizontal plane, correct?
Not that you're standing on it. It's a horizontal plane that's tangent to the surface that you're on.
Listen, I didn't ask you that.
Okay.
What did I
yeah,
ask you?
so there is a tangent plane. Do you know what that is?
Hold on, I didn't ask you that though. Why are you
Do you know what
describing
it's
everything?
it is the
You're
angle
not
of elevation
describing
is measured
tangent.
relative to the tangent
Listen,
plane.
Listen. What did I ask you though? I didn't ask you that.
The angle
I
of
said when you
elevation
take
is
an
measured
elevation
relative to a
angle-
tangent plane.
Okay, your definition didn't say a tangent.
I'm a geometer. This is like my field of expertise.
Oh
I'm using more
my
technical
God.
language.
We're talking about what we read, what we read in when we take a measurement. When we take an elevation
so
angle, part of that
to be
measurement
clear-
is the horizontal plane.
Tangent to the surface, yeah.
So you measuring the surface flat.
No. All
so
surfaces,
you measure
curved
it-
or otherwise, have tangents, have tangential planes.
Is the tangent curved or is it straight? Is a straight line?
Tangents are lines, right? They're not curves.
Or is it a straight line
Tangents-
or curved line?
So maybe I can explain this to you. So
No. See, you're not answering my question. Why?
No, me. I have to explain this. So this orange line that I've drawn here is tangent to the black curved surface, right? That's what it means for a line to be tangent. It means that it kisses the surface at one point and it matches the angle at that point. And if you wanted to draw a tangent at another point, like say, I don't know, here, it would be pointing in a different direction.
You don't have a geometrical horizon to draw a tangent to, though.
I'm not drawing a tangent to a geometric horizon. I'm drawing a tangent.
So what are you
At
using a tangent for?
The tangent is at my feet.
And it goes straight from under your feet all the way out, right?
Yeah, it goes out. It's tangent to the surface at one point and one point
part
only.
Part of your measurement is that straight line, right?
Yeah, sure. That's the tangent.
Okay,
That's the
so
tangent
you're
line or
not
the
measuring
tangent
a
plane.
curve. Part of your measurement is not going to be a curve.
It can still be done on a curve.
Oh my
that-
God!
or
We're
you
not
already
talking
agreed to that.
about
You know that,
Why
right?
are you switching? Why are you switching what we're talking about to what
So
you
to
want
be clear, there are in this diagram there is one curve. It's the black line.
That's the
and there
diagram
are two.
you draw that I don't
Yeah, I
see
know.
in reality.
I know. In this diagram, there is one curve. It's the black line. And then there are two straight lines. Now, if you want to measure an elevation
It's
angle
part
while
of your
standing,
measurement. Listen.
if you want to measure an
part of your
elevation, if you
measurement.
want
Listen.
to measure an elevation angle while standing on a curved surface, you draw a tangent line, that's what the orange line is, and then you draw a line connecting you to the point of observation, and then you find the angle between the tangent line and the angle of
You
observation.
debunk yourself. You just debunk yourself.
That's how you take an angle of elevation while on a curved surface.
You debunk-
I
you
understand
debunk
that
your
this is
argument, you know
confusing
that?
to you.
No,
I understand.
It's not.
But
It's not.
it's
You-
really
you
not a
debunk
good
yourself.
look when you can't understand the simple
Listen,
geometric picture.
You're not taking the elevation angle from the curved surface, though.
You were taking it while standing on the curved surface.
Yeah, but not from the.
The way that you define an elevation angle while on a curved surface is using a tangent line.
Oh,
The
so-
crash out is
okay, are
really
you
funny
saying-
because your laughter is unwarranted here.
So,
It's like
so look,
it's
you're not
showing like a
measuring-
fundamental misunderstanding of
So- so
geometry,
you're
which
not
I
measuring
get
a
because you're a
curve
flat
surface.
earther. But like
So
this
you're not
is
measuring-
this
what
is
are your
like
measurements?
elementary school stuff.
Part of your measurement is not a curved surface. You agree with me? When you take an elevation angle.
You're just measuring an angle. You're not measuring a plane, you're not measuring a line, you're measuring an angle.
Okay, that line, you're on the surface, so that line is going across the surface, right?
You're measuring an angle. When you measure an angle of elevation, you measure an angle.
And part of that measurement is the straight line, not a
No,
curve.
you don't have to measure any lines.
So part of your measurement is not the horizontal plane. When
you measure an angle of elevation, by definition,
part of
you are
that
measuring an
measurement-
angle.
Part. Listen.
There's
Part
only
of that-
one
that
number.
measurement-
There's only one measurement associated with measuring an angle of elevation, and it's an angle. It's a number. It's a number of degrees or a number of radians.
I'm asking you part of that measurement.
There is no part of that measurement. The measurement is one thing. You get out a protractor or a sextant and you just measure an angle.
So you don't have a distance from the observer. So there's not you don't have a distance. That tangent is not a distance from the observer.
When you measure an angle of elevation, you don't measure any distances.
So, okay, that's what I'm asking you. So when you have the observer and you have a line straight from the observer to the GP of the star, right? Part of that measurement is that line.
No, it's not the line. You don't measure the line. The line is not part of the measurement. All you're doing is you're measuring a number, an angle.
Okay, so hold on.
You don't measure distances. You don't measure planes. You're measuring an angle. Now, if you want to make that, like, if you want to draw a diagram to represent this, like the process of like thinking about how the measurement makes sense, the diagram would look something like the diagram I've drawn.
But that's not what I saw in the diagram. That's your diagram.
Yeah, it is. I drew the diagram. You're right.
Okay, you drew it.
Yep.
And you have you're a globe believer. You have a belief. You're in a religion.
You're right. You're right. I do believe the Earth is a globe. You're right.
So you have
science and natural law. Science and natural law. Can I ask you a question? Science and natural law. Can I ask you a question?
Yeah.
Okay. So, what do you think about hurricanes always rotating in one direction in the southern hemisphere and always rotating in the other direction in the northern hemisphere?
Oh, that's the Coriolis effect.
And never crossing the equator.
Is that the Coriolis effect?
It is. So why does that happen?
A Coriolis effect?
Yeah, why does that happen?
Hello?
I can hear you.
You think that's the Coriolis effect?
Well, that's the
globe
explanation. Do you have an explanation for why it happens?
No. I want to educate you. Do you know that's not the Coriolis effect? Do you know that, right?
I believe it is the Coriolis effect. Now, do you have an explanation for why it happens?
Can I educate you why it's not the Coriolis effect?
No, I want you to explain how on a flat Earth that happens.
That has nothing to do with shape. Cause and effect relationship don't have nothing to do with shape.
Can you explain why that happens on a flat Earth?
I never made a claim the cause and effect of a hurricane.
Okay,
why are you asking me
so are you telling me that you don't have an explanation for why hurricanes never cross the equator?
I'm saying I don't have a scientific evidence of the cause of that effect. Do you?
Yeah, it's the Coriolis effect. So to be clear, it sounds like the model.
The Coriolis effect.
No, you asked for the scientific You asked for the scientific explanation for why hurricanes don't cross the equator.
No, I did not. You make it.
Pretty sure you did.
Things that I'm not saying.
Pretty sure you did. So to be clear, science and natural law. Do you have an explanation for why hurricanes don't cross the equator in your model?
I never made any claim of the cause of the effect. I never claimed science.
Oh, wait. So to be clear, science and natural law. So that's not answering my question. My question is, do you have an explanation for why hurricanes don't cross the equator?
No, I don't have any explanation of the cause of that effect.
So it seems like your model has less explanatory power than mine does.
What model? I didn't even give you any model. What model?
The flat Earth model. Any flat Earth model, really.
What? I didn't give you any model. What model are you saying they don't work on?
A model is a way of mentally conceptualizing a real world thing. Your flat Earth view.
No, I don't have a flat Earth view. The problem you're having is
you don't have a flat Earth view. You think the Earth is flat. You do have a flat Earth view.
I don't have. That's what we observe. That's not what. If that was the only thing I hallucinate, I don't hallucinate the flat Earth. That's what we observe.
So you don't have any like mental conception. You don't have any mental conception of the shape of the Earth.
I just observe it flat, and I know we measure it flat.
Okay, so when you think about the Earth, do you ever think about the shape of the Earth? Actually, let's do this right now.
Yeah.
Close your eyes. Think about the shape of the Earth. What shape are you imagining?
I'm doing it with my eyes open. Like a rectangular kind of medium upon medium. See, the Earth is not. See, the Earth only to me means the boundary between air and water. Okay,
so can you finish the thought? What was the thing you were visualizing?
Earth is not a separate. Earth is not something.
Can you explain? Can you finish your thought? Explain the thing you were visualizing.
Okay, I visualize mediums upon mediums upon mediums upon mediums.
Okay, so when you, I don't know what that means. That doesn't sound like any of that's the Earth.
In the vertical direction, you have water. That's a medium. Above water is another medium, air.
Hold on, I'm confused. In the vertical direction, you have water. So like the sky is water.
No, if you was in the bottom of the, if you was standing on the bottom of the ocean, you look up, you would be in the medium of water, and above that medium of water is another medium of air, and above that medium of air is another medium. The medium is within the water and all the way up to the surface.
Okay, and so like what shape are these media? Are they like spherical media? Are they triangular media? Are they like donut shaped media? What shape are they when you visualize?
I would say it's more like I don't know. If I had to choose, I said a triangle.
When you visualize something, you're visualizing something with a shape, right?
Okay, a rectangular of mediums within mediums within mediums.
So a rectangular. So hold on. So I'm just gonna. So I'm gonna try to depict what you are trying to tell me. Okay.
Not even a rectangular. Okay, not even a rectangular.
So we have.
Okay, I'm gonna tell you. You could even pull it up. This one, you could pull up exactly what I'm saying.
Yeah.
You know how they have this thing where they have oil. It's a bottle, right? And then within the clear bottle, you have oil, vinegar, honey.
Yeah. So I understand that you think that there's vertical stratification. I'm asking what it looks like horizontally. Is it like does it just go on, or does it curve around, or is it like a donut shape, or is it like a cube? Like what's the shape?
I would be stipulating.
So what are you visualizing when you visualize the Earth?
You have, like I said, what I visualize.
Are we doing like time cube here?
You gotta let me. No, forget it. I'm changing what I was saying to something else, right? Okay, you could even have that, right? This is a medium of water.
So this is the whole Earth. This is the whole Earth. Is this what you think the Earth is? Is the Earth like cube shaped, and then there's like you have like North America up here.
No.
And then it connects to South America down here. And
can
then
I draw
there's
it
like
myself?
Africa over here.
Can I draw it myself? Can I draw it myself?
I mean, you can try, I guess. Yeah.
All right, let me give you your drawing, because you misrepresenting what I'm saying.
Maybe you think that it's
let me
like.
Draw it. No.
Maybe you think like viewed top down. Maybe you think that it's like. You have your.
You don't have to assume, brother. I will do it for you.
Like
I will draw it for you. Here, let me do it for you.
Maybe it's top down like this, and then there's Africa over here, and then there's Australia over here, and then there's like a whole bunch of Asia stuff over here, Asia, Europe, and stuff. Maybe that's the view that you have, or maybe you think that it's like.
Yeah.
I can't. Okay. Yeah. Okay. Great. So I want a side view if you can.
Okay, this is the water, right? This is the water.
I want a side view. Yeah.
Okay, this is the water. Right?
That's the water.
The water is sitting on a medium.
I
don't know what the medium is. This is a medium. Water.
Yep.
Medium.
And does the water go in all directions forever? If you
left to right, back and forth, only in the vertical direction you change from one medium to another.
Got it.
Right.
And it's like it goes in all directions forever, right? It's just water the whole way.
No, there's a boundary. There's a boundary right here. You see the boundary?
Okay, what's the boundary? Okay, great. So it's like a bucket. It's like a bucket filled with water, and then there's stuff on top of it.
Hold on. Let me see. Can you see? Can you see the drawing? Okay.
Yeah, I can see it.
This is the water. I can't see myself. Can you put me on the big screen?
No, I can't, because there are a bunch of people watching and they won't all be able to see it.
All right. This is so it's two mediums so far. The medium that's holding the water, and then the water is sitting on the medium, right?
Yep.
Then there's air.
Yeah.
I can't even.
And what are the boundaries?
Right here, the boundaries right here.
I understand that there's vertical stratification. I'm asking, like, what are the boundaries? This is the boundary right here. What is it? What is the boundary?
I don't know. I told you we stipulating, because I only thing is, it's like
when you visualize it, what is it?
Look.
Is it like a solid barrier? What is it when you visualize it?
Of course, it's a solid barrier. Yes.
So it's just like okay. So it's kind of like a bucket from your view, just like a really big bucket with like sidewalls.
And then the sun the moon,
Yep.
they're in a lesser air of medium, right? They're in a lesser air.
Understood.
So it's still air. It's still a lesser air of medium. Air
Yep,
is still
understood.
here, less, right? And then above that is the stars.
Yep. Yeah.
The
okay.
stars
So look, I
the
understand.
stars could be in a medium. Look,
Science.
the stars
Science,
could
right.
be in a medium.
I
Another
understand.
medium.
I
That's
understand the
another
drawing.
medium.
Great. I understand.
Another medium.
So in your view, is Earth like a giant bucket of water, and then there's like
It's
the
not
Earth,
water.
but there is
Mediums.
at the bottom. There's okay. So the plastic at the bottom of the bucket is the medium. Then there's the water above that plastic. Then there's the air above that, and then you can imagine that there's like stars above that. So it's like a giant bucket.
Another medium. Where the stars are, it could be another medium.
Yeah, and so it's like a bucket of water, is what you're telling me.
No, it's not a bucket of water because it's not just water there. It's mediums.
Okay, but the bottom thing that's right above the very bottom.
Water. It's not water.
The thing right above the very bottom is water, right?
And below this area is another medium probably.
Okay,
all
great.
we observe
So look,
it's
science
a
and
lot
natural
of
law.
medium.
It sounds like so this is what I mean by a model. Now, on this model, can you explain why hurricanes never cross the equator?
That's a scientific question. It has
You're
nothing
right,
to do
it
with
is.
the model.
I would like
Okay,
an explanation
meaning like-
given the view that you just elaborated on.
It's a scientific question. You would have to cause and effect relationship.
I would love to know what the cause is for why the effect happens that hurricanes never cross the equator.
Okay, what's the scientific evidence for it that you know of?
Don't shift the burden. I asked you a question.
No, but I had already told you. I never claimed.
Okay, so you don't have an explanation, is what you're telling me.
I never conducted I never manipulated any.
Okay, so you don't have an explanation for that. Okay.
Do you have one?
Totally fine.
Not explanation.
Yeah.
We're not asking for an explanation.
I am asking for an explanation. Yeah, I'm asking for
explanation
the
don't mean
reason.
nothing.
I'm asking for
I don't
the
want an
reason that
explanation.
happens. I do. That's why I'm asking for it.
Okay, the cause of the effect, right?
You could call it the cause. I'm asking for a reason. I don't think that like laws have causative power. I think that they are better viewed as explanations, but that's neither here nor there.
There's no law. What's the law? What law? What's the law?
That's a whole separate conversation that you don't want to get into. But look, so science and natural law, it's fine if you don't have an explanation for why hurricanes never cross the equator.
There's no law in hurricane. What's the law in hurricane?
Science and natural law. Look, I understand that this is tricky, but it's fine
not
if you
tricky.
don't
try
have
to
an
play
explanation.
games. You want
If
to
you
be
don't,
funny because you lose in this battle.
we're being very serious. Thank you for the meteor shower, AG. So look, I understand that this is very troublesome. You don't have an explanation for why hurricanes never cross the equator. That's fine. You don't have to have an explanation for everything. Do you have an explanation for why this? Do you have an explanation for why the sun sets to the southwest in Australia during well, you know, in southern Australia it always sets to the southwest if I remember correctly. Do you have an explanation for that?
But why are you asking me things I never make?
Well, I'm just asking if you have explanations in the worldview that you have. I'm asking you if you have explanations for these things.
I don't have a worldview. I'm talking about what we observe.
You just drew me one.
That's not. I didn't draw you anything. This is what we observe.
Oh no, it's not.
You don't
observe.
Have you observed
the boundaries?
We between the boundary between water and water and air.
I'm talking about the boundaries on the sides. Have you observed that before?
It's like I'm eating cow meat, and you say, "Have I observed the cow?" Yeah, I've observed cows in life.
So you didn't observe. So what you're telling me is that you never observed. You never observed the things that are holding the water in.
No.
So it's not what you observe.
No, the cow. If I'm eating cow meat, I don't need to see the cow. I observe cow in life. And if you put a plate of cow meat in front of me, I don't need to observe the cow. I'm eating cow.
I think that you're a little bit lost here. So look, if you had never seen a cow before, and I just put some meat in front of you, you wouldn't know where that meat came from.
But I have.
But right, so you have seen a cow. Look, you have seen a cow. You haven't seen. You haven't seen the edges that hold the water in. So how can you say that you've observed them?
I've seen, because everything I observe containment for everything. If I want a cup of water, or if I
so
want
it's
to bring
not
helium
based on
to somebody,
observation.
I'll
It's
observe.
based on inference. It's based on inference, not observation.
No, it's based on what we observe.
You didn't observe the edge.
So you see me observe me, but hold on. Observing a cup. No, I'm saying the antecedent consequence. Meaning, if
That's an
I observe
inference.
cow and you bring me, if you don't need just the fact that I'm eating cow meat, I don't need to see the cow.
If you want to know where it comes from and you've
So
never
when I
seen a
bring you a
cow
cup of
before, then you
water-
absolutely do. Look, you are making an inference. You are assuming that there are containers there based off of other experiences, but you've never seen those container walls.
I don't need to see it is the thing, because
Okay, so,
we know
so now we don't have to rely on observation is what you're telling me. So now you're telling me that you don't have to rely
I've
on
observed cow
observation?
in life.
You haven't observed just admit it. You haven't observed the barrier.
I've observed cow in life.
You haven't. I
I've
don't care
observed
about
cow and I've
cows.
observed
Science and natural law. Shut up about cows. You haven't
I've
observed the
observed
barrier.
containment.
You've
I've
observed
observed
right. So
containment.
right. Great.
Okay.
Science. Great. You've observed containment, but that's making an inference then that because other things that you've seen have been in containers, therefore the water that you like, the ocean, is also in a container. That's an inference. It's not an observation. You never actually
Just like
made
I
the
observed the
observation.
air sitting on the water.
You never actually made
Listen,
the observation of the barrier. Do we agree on that?
Is the water? I never observed water. Listen, never observed the ocean sitting on land, but I can tell it's sitting on land, right? It's not just suspended, just like the air.
Oh, wait a minute.
A fish
hold
never
on.
been on top of the.
So now we're
let's
doing
say
inference
you have
again.
a sea animal that remains in the bottom.
So science, we're doing inference again. You're
Yeah, well,
you're
we
proposing
experienced
that something
in acid.
exists without having seen
Listen,
it. You're
and-
just doing inference. You're building a model, a mental model, based not off of observation, but based off of inference, which is
No.
fine. Inference is great. We love inference here.
It is of observation. If I didn't observe that, I would.
No, it's
If I
not
didn't-
based on
if I didn't
observation. You
observe that, I
haven't
wouldn't-
seen
I wouldn't-
the medium
wouldn't
that
know
the
that.
ocean is sitting on top of. You haven't seen the barrier that's keeping the ocean in. That's inference. Do you know what inference is?
That's okay.
Wait a minute. Science and natural
Okay, look,
law.
look,
Maybe
okay,
I've
cool.
been maybe
Would you
I've just
agree?
been
Would you
really,
agree,
really
though?
rude. Do you know what an inference is?
I'm inferring
Yeah. Okay. Can you tell me what that means?
something. You inferring something. You okay?
Can you tell me what that means?
You saying okay? Inferring you suggesting that something like suggesting, like you saying, well, you observe any object. Any object you bring into you need a container, whether your hand, whether
I don't want an example. I want a definition.
Well, I don't know the definition. I'm not a definition wizard.
So do you know how the
I
word
can
is
give you an
used?
explanation, but
So, like, for example, like, just how I then, because I don't want to be talking past you. I'm sure you don't want to be talking past me. So let's just agree on what words mean. So, like, if I were to say that I were to make an inference about, about let's say that I have a doctor's appointment, right? And while I'm driving to the doctor's appointment, I encounter a lot of traffic. But I left early, so I'm there on time. But I get to my doctor's appointment, and my doctor still isn't there. And I get a text message. I don't know why my doctor is text messaging me, but I get a text message from my doctor saying, sorry, I'm going to be a little bit late. Now, an inference would be me taking my experience with me being in traffic.
You're doing the same thing I do. That's not a definition.
And then, no, I know. So I'm giving you an example just to make sure that we're in agreement as to that we're using the word
I
in the
gave you
same
an
way.
example as well.
I know.
Okay,
Look, I'm saying examples are okay,
example.
just to make sure that we're agreeing on definitions. So in this example, I would be inferring that my doctor is late because my doctor is in traffic. Now, I never saw my doctor in traffic. That's an inference. But it's perhaps a reasonable conclusion to come to based off of other pieces of data. So do we agree that inferences are conclusions you come to based off of other pieces of data, but not based off of observation of the thing itself?
Okay, that's different. There's different reason. I'm gonna tell you why.
That was a question. Can
I
you
let
say
you
yes
talk.
or
You gotta
no?
let me talk.
Can you say yes or no? And then you can talk.
I said no.
Okay, so you don't
And
think
then I
that
can
that's
talk,
what an inference is?
right?
Go ahead. Yeah, go ahead.
No. Okay. The reason why I said no is because the comparisons are different. This is why the comparisons are different. I never observed somebody bring a cup of water without a container. However, I've seen doctors been late for different reasons. So can you understand that?
Yeah, what you're saying is that you have very, very strong inferential evidence that your inference is correct, which is fine. I'm fine with that, but it is still an inference. It's not an observation.
But here's the thing. But it's different. Yeah, I didn't observe the barrier, but I'm saying I only observe water being brought to me in a container, gas being brought to me in a container.
So your inference.
I always observe things.
I agree.
I observe me standing on the ground. I don't observe me just, not having anything to stand on.
Science and natural law. Right? Look, I agree with you. I think that it's a very good inference, but it's not an observation. And that was the point.
I never said it was an observation.
Hold on, you absolutely did. You said that everything that you described, everything that you described in the picture that you drew was based on observation, but it's not.
Okay.
Right? Some of it's based on inference.
Okay. Yeah, some of it is based on the fact that what I observe, I don't observe. I observe the water, and then I observe the air sitting on the water. So I can come to the conclusion the air is just like the air is sitting on water. The water is sitting on something else. That
is a reasonable inference. I agree, but that means that you are making inferences like I am. So you're not operating solely on observation.
No, I'm not.
You have a mental model for how things are.
What inference are you making?
Then I can ask you questions about how that mental model works. So I mean, the entire scientific process is inference, right? You make some observations in a laboratory, and then you come to conclusions about the natural world.
Okay, look, the thing with me and you, we both starting on a flat Earth. That's what we're observing, me and you. We're not observing a globe.
I don't observe a flat Earth.
So, what do you observe?
I observe a globe Earth.
How?
Because it looks like what a globe Earth would look like.
And how would a globe Earth would look like? How would you know that? How would you know what a globe Earth would look like? Have you ever been on a globe Earth outside of here?
Because I can run the math. I can make predictions about how a thing would look and then compare it with how things do look.
To me, I didn't offer you no math. Look, I didn't offer you no math. Right? What I offer you is
that's a shame. Right? I wish you had.
And it's not a shame to present to you air is sitting on water. You don't need no math for that, do you? Anybody can verify that without a math, right?
But the conclusion about what shape the Earth is based off of that observation is a different question.
I'm not even giving a shape.
You are.
I'm saying
you gave a shape in your drawing.
You twist my arm.
The drawing that you gave had a shape.
Yeah, because you twist my arm because you wouldn't accept the fact what I experienced with you collectively together. You don't want to take that. You want my input. You want somebody else's input. You want somebody else's opinion about it.
I want to know what you believe. Yeah.
Exactly. You into belief, not into what we experience together.
We're having a conversation about what we believe mutually, right? That's the whole point of a debate.
And to believe something, you have to be experiencing something to say, you know what? Since I observe air is sitting on water, the water therefore is sitting on something. Just like above our head.
You're allowed to do inferences, but that is an inference.
But but it's based on reality, what I'm experiencing in reality. Yours is not an experience in reality.
Sure it is.
What is?
The observations that I make are exactly what I would expect on a globe Earth.
What observation? What observation?
Things like the way that the sun moves in the sky, things like the way that ships disappear behind the horizon, things like the way that shadows move on the ground.
How is the way the sun moves in the sky? Hold on, you got to slow down. How is the way the sun moves in the sky have to do with a globe?
Well, so there are certain ways that the sun could move, or the ways that the sun could appear to move if the Earth were a globe, and there are certain ways that the sun could appear to...
How would you know how it could or could not move?
Science, I was answering your question. Do you want me to answer your question? So, if the Earth was a globe, and, floating in space and orbiting the sun, there are ways that the sun would appear to move. If the Earth were, say, planar, if there was no curve to the surface of the Earth, and the sun was instead above it in the sky, there are certain ways that the sun would appear to move. We can compare those with the way that we actually see the sun moving. And what we find is that the way the sun moves is in line with what we would expect for a globe Earth that orbits the sun, rather than for a planar Earth where the sun floats above our heads.
But the issue with that, when you describe how the sun moves in the sky, you describe it from a plane of reference,
I don't know what you mean by
not from a
describing it
curve.
from a plane of reference. I don't know what that means.
Yeah, from a horizontal plane.
Look, we
You
have
describe it from a
observations.
horizontal
Those
plane.
observations are consistent with
Okay, you're gonna
a
ignore what I just said.
globe rather
You
than with
ignore
a
it,
planar Earth.
but you're describing the motions of the sun, the orbit, all in respect to a plane.
No,
a
I'm not
horizontal
describing it
plane.
with respect to a plane. I don't know what you mean by that. Like
What are you describing it in respect to?
you can just describe it in terms of like
I'm not
XYZ
saying what you
coordinates
could
if you
do. I'm
want.
saying what is done. But here's the difference.
The
We're
way
not
that
talking
you
about what you
describe
could be
things is
doing. We're talking about
irrelevant.
what
It's
we're
the way
doing.
things are, and then the way things would appear to
Wow.
be if it was a certain way. And the way things are match up
Okay, here's
exactly
another
with the
thing.
way things would appear to be if the Earth were a sphere.
You never live on a sphere outside of the claim to know what it would have.
And you've never lived on lived on a plane outside of the claim that the Earth is a plane.
That's what
Like
I
it's irrelevant.
measured. No, it is relevant because
the point you're making is
we
irrelevant. We do
describing-
science. The way that we do science is we compare
There's no
predictions with
science involved
observations.
yet here.
This is absolutely
What
science.
science are you talking about?
You have a model, a prediction, a hypothesis, if you will, and then you compare that
Where?
model, that prediction.
Those are just words.
Yes, that's how you communicate in English, science and natural law. You
No,
communicate
you
with
said
words.
these words as if you're presenting them. What have you present as science?
Okay, so do you want me to explain, or do you want to keep talking over me?
I want you to present the science.
So, do you know what the scientific method is?
No, educate me.
Okay, the scientific method is a process that we use to learn about the world around us. The first step is to just look at the world, just to get curious, right? It's not really a necessary step, but it's like usually considered the first step. The second step is you see something you don't understand, so you form a hypothesis. You could also call it forming a guess, or you form a model. You form some potential explanation for why the thing that you're seeing is the way that it is. Then you have to take your potential explanation and you have to convert it into a prediction. So there's some way that the world should behave if your prediction is true. So for example, well, I'm sure that you understand what the word prediction is, so I probably don't need to explain that. Now, after you've made your prediction based off of your guess or based off of your model, I'm so close. I'm so close. I'm so close. I'm so close.
But I didn't know what the prediction is.
Okay, so a prediction is when you have some guess for how something works, and then you think about what that guess would imply about the rest of the natural world, and then you try to infer that if your guess was correct, then you should see this thing. Right? That's what a prediction is. The prediction is what you should see if your guess is correct. Then you go out and you check in the natural world, do you see the thing that you predicted? If you do see the thing that you predicted, then that's evidence that your guess is correct. If you don't see the thing that you predicted, that's evidence that your guess is incorrect. That's the scientific process. Do you understand? Oh.
Yeah, but that don't sound like that don't sound correct. Give me
then maybe go back to like fourth grade, because that's like the scientific method that you learn in like fourth grade.
Okay, look, I'm gonna give you an example of what I just thought I heard you say, and you correct me if I'm wrong. Okay.
Mm-hmm.
Okay. You see a solar eclipse, right? Right? You agree? That's a phenomenon? That's something we see?
Sure.
Okay. We see a solar eclipse and we say, what makes that do that, right? What's making it do that, right? That's what we're asking? What's making this happen?
Yeah, why?
Why? Okay,
why is it doing that?
Okay.
Yeah.
Why is it doing that? Okay. How? Okay. What is the prediction in there?
Well, no. So you can't make a prediction until you've proposed a potential explanation. So you make a guess. You guess, well, maybe it's because of this, right? So you would say, well, maybe it's because there's a giant black orb in the sky that covers the sun. That would be a potential guess, a hypothesis, if you will. And so you would say, okay, so if it's true that eclipses are caused by giant black orbs covering the sun, the prediction then would be, well, you should be able to see these giant black orbs when they're not covering the sun. And so you would go out and you would check. You would look around all over the sky, You would point your telescope in all the different directions, and you'd see, are there any giant black orbs in the sky? Can I see any of them? No? I guess my prediction did not come true, which means that my guess was wrong.
Yeah, there's something just
That's the
off
scientific
about
method.
it. Yeah, it's something off because in your example, it sounds more like you're trying to confirm something. Like you're trying to confirm, like what's blocking something. You go look, right, and you assume it's something you. I don't know why you assume whatever you assume.
That's what the scientific method is. You form a hypothesis, you make a guess, and you go check if your guess is right or wrong.
No,
if your guess,
you don't go check. How do you check?
How do you check
if your guess is right?
By running experiments or by making new observations, whatever way you check, what you do is you try to check to see if You go check if an implication of your guess holds true in real life. If your guess is true, then it must be the case that XYZ thing happens in real life. And then you can go check, does XYZ thing happen in real life?
Okay. See, here's the thing. If because the way you're saying it, it's like, okay, if a car is driving by, and, it blocks something, right? We know it's the car that blocks the thing because we can see the car and we can see the object, right?
You mean like it gets in the way, like it visually blocks something?
Yeah.
Sure.
House, right?
Yeah, you don't need to form an explanation for that because you know what the explanation is, right? You can see it directly.
Yeah, because you can see what's doing that. Now, let's say with the sun, it gets black. We don't have a position. We're not in a position to see what the object is because we're not looking at it from
so we don't know we don't know what's causing it. So we have to guess, and then we can check the guess.
But we don't even need to guess. How about we observe it from a different altitude? Because we're not manipulating anything. We're just trying to see what's blocking it.
So that's you absolutely could, as part of your experiment, you could like go to some other altitude and view it.
Well, you could call it that, but it's not an experiment.
What you would find is
that
you're
not manipulating anything.
So what you would find is that when you go up onto a mountain, what you would find is just the same thing, and you wouldn't have any more information than you used to have.
But that's not true. How do you know that? Have you ever observed the
Have I ever observed an eclipse from a higher altitude than from a lower altitude? Yes, I have.
Okay, what was it? What was it?
I've observed an eclipse. I've observed an eclipse near sea level, and I've observed I can't speak. And I have observed an eclipse that's like 1,000 feet above sea level.
1,000 feet from a mountain? What is it?
No, it's just the inland.
I'm talking about, come on now. We have equipment that can go higher than that, man. I'm talking about the highest we can go from. We don't even got to go the highest.
This seems irrelevant. The eclipse was an example. In fact, it was your example of what we can apply the scientific method to do. The point is science and natural law. I was trying to explain to you how the scientific method works. And now you're saying, cool. You don't have to apply the scientific method to an eclipse. You could just try to observe it from a different perspective. That's not the point. The point is I was explaining to you how the scientific method works. If you don't care about that, that's fine. But that doesn't make my explanation any less true.
No, I care. But the problem is, in your examples, you're not worrying about manipulating anything. You gave me an example of how you assume it's some kind of, it's whatever.
That was your example. The eclipse was your example.
No unicorn. No. Listen, you told me you think what caused the solar eclipse is a unicorn. Not a unicorn, but I can't remember the word. It's a unicorn, but you go outside, you don't see no unicorns. So therefore, it's not a unicorn blocking it. Right? That's dumb because I don't know why would you think that's what's blocking it. You could say maybe one of the other lines.
This is such a lost cause. Look, the way that you rule out possible explanations is you check whether or not those explanations agree with your observations. And if they don't agree with your other observations, that's the scientific method.
Okay, cool. But what I'm talking about
science and natural law, we are down a deep rabbit hole. It seems like there's no way that you will ever be able to learn about the natural world unless you actually learn how the scientific method works. So I would suggest taking the name science out of your. I would suggest you take the name science out of your name. until you understand the scientific method.
I do understand the science.
Bro doesn't understand the scientific method. He asked me to explain it to him. What? All right. We have some super chats to read. We have a lot of super chats. I'm sorry I missed all of them. All right, and then we'll bring up our next guest. So we have Marvelous Confetti from Peter Hegwood. Thank you so much. We have $10 from Interstate 5. Thank you for the $10. Interstate 5 says, Eratosthenes accurately calculated the circumference of the Earth 2,200 years ago without the aid of modern instruments. BTB, as a short king myself, we love you too. Yeah, we love our 6'1" short kings. Brenda Lee sent a star map of Polaris for the 500 joules. Thank you, Brenda. Wiz Nilly sent $2. Thank you. Bingo, you think that he watches Nathan Oakley? Of course he does. Of course he watches Nathan Oakley. The first guy, I think. War Crazy sent $5, sending, this guy doesn't need to worry about the shape of the Earth. He just needs to get a job as a janitor. I don't want to... Let's not degrade people. Also, janitors are a necessary job. Grimmy with the $5 says, is Guest struggling with basic geometry? Also hydration? Yeah, Guest was. Brian Peck sends $5 for, they have been told by Nathan Oakley that the horizontal line in an elevation angle is running along the surface. It's nonsense from a grifter. Yeah, that's what it boils down to, unfortunately. Peter Hegwood sends $5. Blitz, you need a soundboard to play Jeopardy music when they say, give me a sec. Yeah, that's a good idea. I should get a soundboard. I think that there is one in TikTok, actually, but it won't play everywhere. From Kung Pao Chicken, we have $20. Thank you so much. That's so generous. Can you find a more advanced flat earther? This guy's brain is flat. The advanced flat earthers avoid me because they know their grift won't work on me. Grimlock again sends $5. I wonder if Guest knows that both Borealis can't be visible on a flat earth model. Maybe they don't even know that there are two of them. Flat earthers don't like to claim to have a model. That's the issue. AG sent 3,000 joules in the form of meteor shower. Thank you, AG. Hasselblad, my good buddy Hasselblad, sent a happy Friday for 400 joules. Apocalypse sent a money gun and sunglasses. And do we have anything else? By the way, I'll read ones that are like 199 or more. Otherwise, there's just too many. I do appreciate everybody sending 1 gem or 1 joule or 10 joules. I do appreciate that a lot. It's just, there's just too many to read. ZH Kane sends 5 Australian buckaroos. Thanks for the stream. C-Bar sends, can you please enable super stickers? Oh, yeah, I'll have to figure that out. DM me after the live is over and I'll work on it. And Battery Bill sends 299 joules. Thank you so much, everybody. All right, let's bring up our next guest. Now, we do have a guest from YouTube, I believe. Let us talk to Noodle. Can you hear me? Okay. You know, that doesn't get people banned anymore. Like, it's just, like if you do that in somebody's live, it doesn't get anybody banned. Well, it doesn't get me banned anyway. All right, let's talk to Thugonomics. Hey, how's it going?
Good. I'm sorry about that last guy. That was kind of weird.
It's okay. That's
yeah.
It's children being children. So Thugonomics, what shape do you think the Earth is?
I think it's flat, but not in the traditional sense. Is it cool if you pull up you have like this Microsoft Paint thing you got? I see sometimes you draw stuff.
Yeah, sure.
Yeah, could you pull it up so I could kind of describe how I think it looks like?
Sure. Is there a name for the model, by the way? Just how then I can like.
No,
is it
no.
Googleable?
I think I saw it somewhere, but I'm not sure about the exact.
All right, we have Microsoft Paint. What am I drawing?
Yeah. So so can you draw like just a circle, like a normal circle? Yeah. So if you imagine it, if you tilted it horizontally, right? So it looked flat.
Like that?
Yeah. So I think like bits and pieces of it, right? Like for example, let's say like the left edge, right? It's like tilted downwards a little bit, and that's like all over the planet.
So, oh, okay. No, I actually do know what you're talking about. Let me see if I can pull up a picture.
Yeah. It's kind of like if you cut out a circular piece of paper and then kind of made a bunch of little different folds.
It's like turning a plate upside down, right?
Not necessarily. I guess. So maybe like one part of the plate, right, where like tilts downwards. If it's upside down, it kind of looks like that. But then another piece would be kind of lifted up. So it's like different all over the place.
So, okay, maybe I'm actually not. Maybe I actually don't know what you're referring to. So it's like this, except, like this.
Here, I think this is a better way. So can you just draw a straight line across and just imagine it's like from the horizontal view, right?
Yeah, we're
So
looking at it from the side.
Can you draw a diagonal line on the left side, like on the left corner of the line?
Like this way?
Yeah, yeah. And then on the right side, can you draw like a line going up?
Oh, like this way?
Yeah, it's like that kind of, but it's different in all like every single area, right? And yeah, that's how I think it looks like.
So I'm
So it
confused.
goes up and down in different areas.
So like you mean mountains and stuff?
Yeah, but it's on a grander scale.
Okay,
Like for
so
example, according to
why
the
do you
globe
think
model,
it's this
right?
shape?
Well, because if you get like the traditional flat Earth model, right? There's a lot of things that can't be explained, right? Because like the sun and stuff. But if you use this model, you can it conveniently explains things that, like for example, in Australia, right? I think you're talking to the last guy how you couldn't see the sunset. I think it sets in the southwest, right? So that couldn't be explained on that type of model because it wouldn't make sense. But on this model, it'd be obstructed.
How is it explained on this model?
Well, here I'll put it this way. So, from 14,000 feet up, right? What is the furthest vantage point from 14,000 feet?
I don't know off the top of my head. I could go pull up a calculator
Yeah.
and calculate it for you if you want.
Is there like a specific equation? I think there is, but
there is. But there's a guy named Walter Bislin who made a pretty good calculator that takes into account a lot of the good geometry and stuff. So we want 14,000 feet, you said?
Yeah. Do 14,000. Can you do 14,400 exactly?
14,400. Yeah.
Yeah.
That's the observer height, and yeah. So then you should be able to see. Where's the thing? 146 miles.
Okay, so is 146 miles the
147-ish.
Yeah, would that be the absolute cap, or could you see a little bit further if there was
That
other?
would be the distance to the horizon.
See, that actually doesn't make sense.
Why not?
Well, I've been on a mountain that was exactly that height, and I could see places that were over 150 miles away.
Yeah, so what is the case is that this is the distance to the horizon with no atmospheric effects. Depending on what the atmosphere is doing, you could have, especially if you have like a particularly hazy day, you could see significantly further. And this is not so surprising, right? Like mirages are a thing that happen on the ocean, for example. And so obviously there's atmospheric stuff that happens. So with standard atmospheric refraction, which this is built into the calculator, you can see 156.7 miles. And that's how far away the horizon would be. Now, if there was a mountain that was 170 miles away or so, for example, you would be able to see that because it would be peeking up from behind the horizon. Yeah,
because I was interested in that because in like different parts of the world, right? For example, like in some places, even if the mountain is shorter, in some cases you could actually see further. Like I think the furthest vantage point is like somewhere. I think it's like somewhere in the Alps, or I'm not really sure, but it was like over 200 miles ish.
Yeah, so look, there are places that like there's a famous example that you can see. Like if you're somewhere in France, there's like a peak of the Alps that you can see. That you can see at like a certain time of day on certain time of year or whatever. And what you're seeing is you're seeing one mountain peak from another mountain peak. And so if, for example, if you were at a 14,400 foot tall mountain and you were looking at another 14,400 foot tall mountain,
Well, I'll tell you the exact numbers. I was on a 14,400 foot mountain, and the other mountain I was looking at was about 10,000-ish.
Okay.
And there's different mountains. It was just in the Pacific Northwest because I was on top of Mount Rainier.
So you should be able to see that mountain, at least like the top of that mountain, from when it's 285 miles away.
Oh, 285? Is that from the 14,400?
Yeah.
Okay.
So and that's because even though the horizon. And I'll just draw a picture. Hopefully this will help. So here you have, obviously not to scale, but hopefully it'll explain what's going on. So let me make this a little bit thinner. That's too thin. So you have mountain 1, obviously not to scale, and then mountain 2, like here, something like this. Now, if you're standing on top of mountain 1, you could see the top of mountain 2, right? Nothing's blocking your view. Okay. Even though the horizon is here. The horizon is like how far away you can see the ground. Like you can't see the ground over here because there's ground in the way. So the horizon is, you know, only half as far away as the top of the mountain that you can see. So that's why you'd be able to see a mountain further away than you could see the horizon.
All right, that makes sense.
Yeah. Well, anything else, Thugonomics?
Wait, can you pull that up again really quick? You said
Sure.
So you can't see the ground past the other mountain, right?
Yeah, so the blue line is the distance, is where the horizon goes to. The black line is your vantage point to the other mountain.
When I was there, I could also see the ground too, or not next to it necessarily, but I could see ground past it.
You'll see ground, but you won't. Yeah. But that ground won't be behind the mountain, and it won't even be near the surface of near the foot of the mountain. It'll be significantly closer, but it'll look like it's at the base of the mountain because you are seeing precisely the stuff that you could see is precisely this stuff. So you will see. So at any angle that you're looking, below this blue line, you will see ground, and then once you start looking above this blue line, you'll start seeing mountain. So it'll look like it'll go ground.
That does kind of make sense because so I was on another mountain that was about 10,000. I think what you're saying makes sense, right? And then in the distance, I could see like multiple mountains, like 4 mountains, and then one of them was like way taller than the other one, but it looked shorter, but it was like way further in the back. So it just looks like that because of the curvature, right?
Yeah, so in fact, I've actually seen Mount Everest in person, but it's kind of far away from where it's amazing, by the way. But from kind of far away, it doesn't actually look like the tallest mountain because there are mountains that are closer, that are slightly shorter, like maybe 1,000 feet shorter or whatever. But there are mountains that are shorter. They're just closer, so they look bigger.
But it's also like on a pretty high plateau. So like the base.
Yeah, that's also true.
You start out like 16,000 feet, and then like for example, like Denali and stuff, they start off like way lower, so it looks way more. Yeah, it looks like way more.
Denali, I've heard, looks very impressive.
Yeah, I mean, I've seen all those ones, and they look much more impressive than. Oh, I mean, I've never been to Everest, but
I mean, it's Everest is very impressive, but like it's just the Himalayas in their entirety are just like
they look huge.
It's just, you know, I can understand why people would have like religious experiences, right? Yeah. Anyway, Thugonomics, I'm going to let you go, but thank you so much for being here. I appreciate it.
Thank you for debunking me.
Yeah, fair enough. Take care. I wish that my keyboard weren't. This is the first time I've ever wished that my keyboard wasn't so loud, because I know you guys can hear it. I'm just taking notes so then I can write down stuff for later clipping. Right, so do we have any guests on? So we actually have no guests right now. Oh, let's read some super chats, and then we'll bring up the next guest that we get. So we have Tim, who sent a galaxy. Thank you for the galaxy, Tim. And Kurd Dede, I think that's how you say it, sent a big bouquet. More useless takes sent $2 for dude, love your channel, never stop owning the FLERFS. Look, I would never stop if they never stop showing up. And then from Shards with the 7 Canuck bucks, some people just rather keep feeding a lie they've been told instead of admitting that it was one. It's an ego thing. Yeah, it is an ego thing. All right, we have Euler Gauss Newton 1, 2, 3. Euler Gauss Newton, how's it going?
Yo, the Earth is flat, bro.
Okay, why do you think so?
Bro, it's just obvious. You walk out and it's just flat.
This is a troll.
What?
Nobody with the name Euler Gauss Newton would be a flat earther, by the way. That's how I know. Calvin, how's it going?
Hi, I am not a flat earther. I actually just had a couple questions about your education and like what specifically you learned about and what got you into this topic. Because I love debating with people, especially on things like flat earth, and was kind of just curious where you pull most of your information and how you've learned all of this.
Yeah, so I have a PhD in physics. That's where it comes from.
Okay.
Yeah,
I assume it was like physics or geography or something.
Yeah. So like all of this stuff, all this geometry stuff, all the stuff about gravity, all the stuff about like pressure and all that stuff. That's just like stuff that I learned during my, not during my doctoral work. You learned that during undergrad, but yeah, that's when I learned that stuff. But Calvin, I'm gonna let you go because there's 3 people in the queue. But thanks for being here.
All right. Goodbye.
All right, let's bring up Karma. Karma chameleon. Karma, how's it going?
Good, how are you?
I'm doing all right. What shape do you think the Earth is?
I think it's flat.
Okay, and
I
why?
really do. Because no matter how far I go, how far I travel, I just don't really see like it like becoming a circle like an apple. Like I've not got a PhD in physics like you do. I know you're well ahead of me with that, but I do. The one thing I do know is that like I know gravity, like the apple falls in that, but like what's saying that the Earth is actually round? Like,
Are you asking what the
otherwise,
evidence is?
yeah, like what's the evidence apart from photos of like space?
Well, so photos are
Um,
generally pretty widely regarded as pretty good evidence, right? But if you don't trust photos, I guess that we can talk about other stuff. It's just more indirect. So, for example, there's kind of two competing worldviews here, right? There's the globe worldview where the Earth orbits around the sun and the moon orbits around the Earth and the Earth is a sphere and it spins. And then there's this worldview where the Earth is kind of flat, and the Earth and the sun and the moon are in some sense above it, and they're kind of moving around above it, right? So what we need to do is we need to compare those two views. Now, on a globe Earth, one would understand that Antarctica, the ice continent in the very, very south, is fairly normal size for a continent. I think it's like the size of Australia or something like this. Whereas on a flat Earth, Antarctica is the largest continent because it goes around the edge. Everything else is in the inside, so it must be smaller. So there's a good question. Can you sail around Antarctica, and how long does it take? How fast are you moving, and can we figure out how long it takes to go around? And in fact, there actually is such a thing. It's called the Antarctic Yacht Race, if I remember correctly. It's just a bunch of rich people get in their sailboats and they sail around Antarctica. And you can just check the amount of time that it takes these sailors to sail around Antarctica and the speed at which they're sailing. It checks out that Antarctica is fairly small. They end up traveling like 14,000 miles or something like this. But that's far too small to be the ring around the Earth. So that's one way that we can know that Antarctica isn't a ring around the Earth, and hence the Earth isn't flat.
Yeah, but also though, we could say that because there's no one like we really know that have like went to the edge of the Earth and then like fell off, or like come back to tell the tale. But that might just be because they fell off the Earth, so they're just like
Oh, is this a troll?
floating in outer space. No, they'd be like because they could just be floating like, and like you know those photos.
Oh yeah,
that
this
I
is a
said,
troll.
No. This ain't a
Flat
troll.
Earthers don't think that there's space.
No. When I look up, because I got given a telescope and I see like
It's a troll. Here I am actually giving a genuine explanation. Wesley, how's it going?
Yeah, good. How are you?
I'm doing all right. What shape do you think the Earth is?
Whoops. Hold on. My bad. All right, can you hear me?
Yep. What shape do you think the Earth is?
It's flat.
Okay, why do you think so?
Well, I live in Indiana,
Mm-hmm.
and my wife's parents live in Michigan, so we go up to Michigan a lot. And so, there's a place called St. Joseph, Michigan, which is right on the lake Michigan there. And on a clear day, you can see Chicago quite clearly, day or night.
Really? Okay, so what's this place called?
St. Joseph, Michigan.
St. Joseph, Michigan.
And
This is fascinating if true. And then you can see Chicago from...
which is 60 miles away. And, the curvature or the curve...
Do you have any pictures that have been geolocated to St. Joseph that you can show me?
I took pictures of the at night and in
Because
the day.
I have to tell
And
you,
then up-
I've had
and
people
then
tell me
if
this
you go
before.
up to Muskegon,
So I've
Michigan.
had hold up, just
Yeah,
before
yeah.
we keep going. I've had people tell me this before, and they'll go point me to a video that they found. It's a video by by a fellow named Nathan Thompson, and they'll say, well, he was in. I think that they actually usually say that he was in. Is it Benton Harbor? I think is where he usually is where he says that he was in. And then he'll say, but Benton Harbor is like 60 miles away from Chicago, and you can see it, and that doesn't make sense on a globe Earth. But it turns out, at least in that video's been geolocated to Evans Dunes, which are like 30 miles closer. And so, like, every time somebody says this, I'm very, very skeptical that this is true, because I've never actually seen a correctly geolocated photos from that far away that see Chicago.
Okay, well, I've done it. And then we've gone up to Muskegon, Michigan, and you can see
I don't know where Muskegon is. Okay, there's Muskegon.
Milwaukee, and that's like 70 miles away.
Really? Okay, so if I were to Google Milwaukee, does it have a skyline?
Yes.
From
Not
Muskegon.
like Chicago's, but you can
but you can see it. So if I were to Google Milwaukee skyline from Muskegon, I mean, other people would have seen this, right? So I should be able to see. I should be able to see see this skyline that you're referring to.
Yeah.
From Muskegon.
Yep.
So I'm not seeing anything that says that we're seeing.
Well,
any of these.
I've done it, and I've done it.
So, like, is it a one-off thing? Is it a thing that happened more than once? Is it on the regular?
Oh, yeah, we go up there quite a bit, and some
do you
days
see it every time?
There's so much overcast or humidity in the air you can't see it. But on some days you can definitely see it.
So right. So are you familiar with Fata Morgana?
No.
It's a type of mirage.
Yeah.
And it's a type of mirage that kind of inverts.
This is definitely not a mirage.
So I actually found this is from Michigan Live. I guess it's a Michigan website, a Michigan Michigan news website or something like this. I can show you what I'm looking at right now. So I found one source for perhaps what you're seeing, and this would be great. So here we have the lights of Milwaukee were seen Thursday night from the Lake Michigan shores of Muskegon, which sounds an awful like what you were saying. And it says the technical term is Fata Morgana.
Yeah, they're just throwing that out because
But why can't so hold on? But let's keep reading.
I'm looking right at it, and you can say that it's that.
Let's keep reading. The rare atmospheric condition allows light 80 miles across Lake Michigan to be seen as if one were looking from one shore to the other of Houghton Lake. I don't know what Houghton Lake is. But the point is that this doesn't happen every day. Otherwise, they wouldn't call it a rare atmospheric condition.
Yeah.
If it were the case that the Earth were flat, you should be able to see it every day, right?
Well, not necessarily, because
Why not?
the humidity, there's things in the air that
So why
some
can
days are not as
most
clear.
days you can't even see it most days, right?
Well, yeah, because it's not as clear. It just happens sometimes.
So how much would you want to bet that? And we could just this is an experiment that could even in principle be run. If you were to measure the atmospheric temperature as a function of height over Lake Michigan, on days when you could see it, it would be quite rare.
Yeah, I wouldn't know anything.
As in, you would have a temperature inversion. So rather than having the temperature go one way with altitude, it goes the other way with altitude. Now, I would bet that on the days when you can see it, you get a temperature inversion, and that's what causes mirages. That's what causes things like Fata Morgana.
Well, okay, I get all that scientific stuff is what they're saying, but there are just other things that sort of puzzle me.
Like what?
Well, the same stars. I mean, the stars are always the same. you know, I have a telescope and I look at frickin', you know, Jupiter, Saturn, you know, all those, you know, so-called planets, and they really don't look anything like what NASA shows me.
What kind of telescope do you have?
I'm just wondering if
what kind of telescope do you have?
Just a regular old freaking telescope. I mean,
what kind of telescope is it?
I can't remember exactly what it is. It's cheap.
Is it a refractor or a reflector?
It's a refractor where that, you know.
How many inches?
You know, it's not that big, but I can still see it, and you know,
because, I mean, I've seen it too. I've seen it. You can actually see Jupiter through binoculars, even because Jupiter's fairly large.
Yeah,
and you can see it.
See, like my thought is
you can definitely see that. You can even see the rings of Saturn.
Sun is
actually,
93 million. Yeah, I get it. I see it.
Mm-hmm.
But if the sun is 93 million miles away from us, and Jupiter is further away from,
so Jupiter's like 200 million miles away or something like this. I can look it up.
Now, how the hell are we seeing the sunlight from our sun reflecting off of the supposed gas planet? I don't.
Because it's really big
get it.
And it's very reflective.
How can gas be reflective?
If you have a lot of it, gas is no longer clear. I mean, like, and you know this, right? I mean, the sun, or not the sun, the sky is air, right? And we usually think of air as being clear, except it's not clear when you have a lot of it. It gets blue.
Yeah, you know, I don't know nothing about that. I'm just saying.
Hold on. Don't. Sorry, I can't think of the word. Don't sell yourself short. You know that the sky is blue, that the air is blue, because if you look at distant mountains, those mountains get blue tinted. You know this. I'm sure you've seen this.
Yeah, but you know, I've also seen the moon. You know, with it looks like our atmosphere is behind it. It's blue.
No, our atmosphere is in the middle of it. It's between us and it. That's why you're seeing it filtered.
Another thing,
a blue filter. Hold on, no, please. Before we move off of this, please acknowledge that there is an answer to this question.
Well,
you can't just say, there are some things that don't really work on the globe Earth, and then I give you how they work on a globe Earth, and then you just pivot. Like, you gotta at least acknowledge that either A, you didn't know the explanation and now you do, great, or B, you have some rebuttal.
Yeah, I wouldn't have a rebuttal because, you know,
the same reason mountains are blue
when they're off. Graduate, you know,
the same reason mountains are blue when they're off in the distance is the reason why the moon appears blue during the day.
You know what? I just don't see mountains because I'm in Indiana. So
you've never seen mountains before?
I have been to the Rockies, but you know, I've been, you know, in the Rockies. You know, they're not that
okay,
far
let me show
away.
You a picture then.
They don't look blue to me.
Let me show you a picture, or a series of pictures even. I just Googled mountains from a distance. See how they're all getting like that blue tinge? Like, look at this one. Or like, look at this one. Or this one. This one might be fake. But like, look at this one. See how they're getting like blue tint? The further away they are?
Yeah, well, whatever.
This is like, I live near the mountains. Like, I live in Arizona. We're surrounded by mountains. Like, this is like a real thing. Like, even this one, like that mountain is bluish. Oh, sorry, you can't see it. That mountain is bluish, right? It's not actually a blue mountain. It's getting a blue tinge from the sky.
All right.
So like this is a thing that happens, and it's the exact same reason why the moon appears blue.
Is air gas?
Yes.
Well, then how can we keep it here on Earth and not going through, you know, the supposed vacuum of space right next to it?
Gravity.
Yeah, that's what they say, but God, that's not, you know, that's like me saying, come to my barbecue, but bring propane, but don't bring the tank. You know, it doesn't make sense to me because of the laws of thermodynamics.
If you had like a giant gravitational source in your, like, attached to your grill, then yeah, you wouldn't need to bring a tank. Well, they might need to bring a tank to transport it because they don't have the gravitational source. But the Earth is a giant gravitational source, so it pulls stuff to it. Not that complicated.
So I can use a straw and actually, put it in a cup of water, and with my weak ass lungs, I can just pull in the water. What's holding it? Why wouldn't gravity hold it down? I mean,
there's a reason why you
how
have to
can we
look.
pick
If there
up
was
our arms or jump up in the air, I mean,
Wesley,
none of that makes sense.
Wesley,
I mean, it
why
just
is
doesn't
it
make
hard,
sense.
Wesley? Why is it hard to lift a 50-pound dumbbell, and it's not that hard to lift it's not really hard at all to lift a 5-pound dumbbell? I'm talking curling, right?
It's the density of it. I mean, whatever. I mean,
well, no, they don't. They could be the same
I can
density,
lift
right?
things that my wife can't.
They can be the same density. One's just smaller than the other.
All right.
One's smaller and it weighs less. Why is it harder to
still
lift
haven't
50 pounds than it is to
convinced me
weigh?
that we live on a ball
Why
flying.
is it harder? Why is it harder to lift 50 pounds than it is to lift 5 pounds?
Well, my wife can't lift 50 pounds, but I can.
Why is it
But you know
harder
what?
to lift 50 pounds than it is to lift 5 pounds? This is a really.
Because it's heavier.
Why is it okay? What makes it heavier?
Because it's got more mass.
Okay, how is mass related? Because mass is just how hard it is to push things around, right? So what does mass have to do with how hard it is to lift something up?
I'm just not sure what you're saying, actually.
We got that.
You know what? I'm on lunch hour, and I was just scrolling through, and I was like, I got lots of questions, and none of it's being answered. But,
to be clear, I answered all of your questions.
Well,
don't be dishonest and say none of it's been answered.
No, you answered it the same way the textbooks answer it.
So then what do you mean none of it's been answered? You know that there are answers. It's not none of it's been answered. You just don't like the answers.
It's just not what I'm looking at in the real world.
What experiments have you run in the real world?
What do you mean?
What experiments have you run in the real world?
In the real world,
yeah.
And what
experiments have you run?
Every day of my life
is
the same sun rotating around us, the same moon rotating around us, the same stars rotating around us.
Wait, no, that's not right.
If
it's not the same stars.
If we're traveling through space at billions of miles every year, why would
I don't actually think it's billions of miles every year. But Wesley, do you want an answer to your question? Do you want an answer to your question? Do you want an answer to your question, Wesley?
Well, you can't answer it.
Sorry. I can. I have an answer for you. You have to shut up for a second, and I will answer your question.
Sorry, I'm out of here.
Oh, putting on your running shoes. What a coward. All right, let's read some super chats. We have a massage from Crazy Catwoman. Thank you. Although, we don't know each other that well. Math Josh sent Happy Friday. Grub Army sent 1,000 joules on YouTube. This is like a new thing. Like you can send gifts on YouTube as well. Although I think that still super chats are better. Pat in the chat sent $5 for Dear Mr. Indiana Man. Your incredulity is not an argument for flat Earth. You're right. That's exactly what it is. It's unfortunate, but that's the reality that we live in. There are a lot of people who are very incredulous. Let's talk to Fish. I love talking to some fish. Hello. Fish, how's it going?
It's good. I'm sorry. I'm not one of these idiots. I apologize. I just wanted
be
to
nice to them. They were born this way.
I'm sorry.
All right, ask
first
me a quick
of all,
question.
I can't believe how the questions you get. Could we not simply prove these people wrong by setting up a laser on two ends of a body of water and showing the curvature throughout it?
They wouldn't believe it. Like
That's
this has been done. This has actually been done.
Of course it has. And then I just have another really quick question. I just watched a video of yours talking about using a black hole as a battery to power a light, and I'm curious, is there any reason why we couldn't devise a device that would use the extreme gravitational pull to create electricity?
You can.
Or
It's it's called the Penrose process, and I do have a video on it. So look that up on TikTok.
Oh,
look
okay.
up Penrose process.
I will do. Thank you.
And yeah, you'll see it. All right, later.
Thanks a lot. Bye.
Yeah, there is a separate point that lasers over water aren't great. Lasers diverge, and also refraction will ruin your measurements. So typically what you'll want to do is you'll want to do like reciprocal zenith angle measurements. Those are really good. All right, let's talk to Tayo. I think I've spoken with Tayo before. This name sounds familiar.
Yo, hello.
Tayo, how's it going?
Not too bad, thanks. What about you, man?
I'm doing all right. Have we spoken before, like a long time ago?
No idea, man.
Okay. Anyway, what shape do you think the Earth is?
I think it's a sphere, but I'm on this live because you said like the air is blue or something.
Yeah, it is. Air is blue.
Have we compressed the like air before?
You can see it's the sky. The sky is blue. That's air. But yes, oxygen is also blue. Liquid oxygen is actually blue. All right, let's talk to Star Wars stuff. Star Wars stuff, how's it going?
Hello, are you ready to get owned with math and logic?
Tyler, is this you?
No. I don't know who Tyler is.
Get out of here, Tyler.
Oh, this isn't Tyler. I don't know who that is.
Turn on your camera.
I don't know if I can. I don't know if I have enough followers.
Okay, never mind. It's not Tyler. Okay, so math and logic, it's not. The way that he said he doesn't have enough followers, it's not Tyler. I don't think anyway.
So, an ancient Greek mathematician actually proved the Earth was flat over a topology which does not conform to the parallel postulate. So what do you think about that?
It's not flat if it doesn't have the parallel postulate.
It's flat over a non-Euclidean geometry.
It's not flat then, if it's non-Euclidean. All right, Star Wars stuff. Go on. It actually may have been Tyler. It's hard to tell. Yeah, take that, science boy. Co-op, how's it going? Oh, and he ran. Let's talk to Isaac. Your mom is non-Euclidean. Yeah, Glowman's voice is much more cheery, but it may have been a bit. Isaac, how's it going?
Hey, I'm doing good. How are you?
I'm doing A-okay. Isaac, what shape do you think the Earth is?
I think it's a sphere. I just have a question. I'm sorry you're getting
Make
a lot
it
of
quick.
people to the sphere. Yeah, I know. Make it quick. I have a lot of friends who think the Earth is flat, and they go out and throw it to me like they can't. They honestly, I just need to know how to combat them because they always get me into a circle. They basically just saying that everything that they look at and through like telescopes and that space doesn't exist and stars are just holes of light coming through the speakers and stuff like that through the things. I don't know how to combat people like that, and if it's just.
So what you can do, there are a few things that you can do. So one is, and these are just like simple, easy things that flat earthers like have no explanation for. So one, you can ask, why is it that there are any days of the year where in southern Australia the sun sets to the southwest? And the reason why that's relevant is because on the flat earth model, the canonical flat earth model that all the big flat earthers adhere to, the sun goes around above the earth, above certain lines. It's this one that's in the background here, right? And in particular, in their view, there's a point on the earth directly below the sun at any time of the day, any time of the year, and it never goes further south than the Tropic of Capricorn, which means that if you are further south than the Tropic of Capricorn, you will always see the sun setting to the northwest because it's swinging around, and so it'll be to the north of you at all times. The sun will never be south of you. And yet there are days of the year where if you're in southern Australia, for example, you can see the sun setting in the southwest. So that's something that they can't explain. It works perfectly well on a globe Earth, by the way, but they will never be able to explain that. The second thing is that there are flight paths. There's a flight from Santiago to, which is in Chile, to Sydney, Australia in the southern hemisphere. And then a nearly identical flight in the northern hemisphere from New York to Tokyo. You can look up these flights. They're direct flights. You can go into flight path radar and you can show them that the flights are mirrored. They're the exact same flight north and south. They're just mirrored across the equator. They take the exact same amount of time, or nearly, with like, you know, plus or minus 30 minutes to an hour, depending on weather. But if the Earth was flat, it should take so much longer to go from Australia to Santiago and back than it does to go from New York to Tokyo. So those are two good ones that you can bring up.
Cool. Okay. I don't want to take too much of the time that you have to do this. I just wanted to question, because like they go up to me and they'll just tell me like that everything is wrong. Like even to the point where gravity isn't actually gravity. It's like electromagnetation or something like that.
Yeah, so they're going to do that. All you have to do is just like give them an example of something that they can't explain. Like, why does the sun set in the southwest in southern Australia? Like that's they will never have an explanation for that. If they do, their explanation will be like, oh, well, there's like a parabolic non-Euclidean field of view and the light is bending to your, like they'll have to like basically make shit up to try to make sense of it, to have like the light bend around the like they might make some shit up like that. But then it's just a matter of being like, look, doesn't that seem like counterintuitive, that like that shouldn't be necessary to explain this? So that's what I would do.
Okay, thank you very much.
Of course. Thanks for being here, Isaac.
Yeah, thank you.
All right, so our guest box is currently empty. We do have another hour or so left in the stream, so if there are any flat earthers in the chat, I know that there's 750 of you guys in TikTok, and then another, another 900 on YouTube. So there's like 1,600 of y'all. You can join whether you're on TikTok or on YouTube. You can join by going to this link, or if you're on TikTok, you can join via the link on TikTok. Sorry, I don't mean link. However, make sure that if you do join that you are a flat earther. I understand that people have questions. I understand that people want to talk, but I do want to, you know, restrict this live. Like it does say opposition only. So I'm going to be more strict about it, okay?
Hi guys.
Pretty sure that was a child. Was that a child? I mean, alternatively, like maybe we defeated the flat earthers, right? Yeah, so there's two YouTube streams, by the way. There's a vertical stream and a horizontal stream. The vertical has 545 or something. The horizontal has like 360 or something like this. So yeah, guys, I think we did it. I think we beat the flat earthers. Oh, I think that these are all the same. I think that this is a bug on YouTube because I don't think Grub Army sent like 1,000 joules 100 times. But yeah, I think it's a bug. By the way, so let me show you guys some things. Let me show you guys something neat. While we have time. So I have a flat earth debate note thing, right? It has a whole bunch of different topics. I have flat earth, theism, young earth, MAGA stuff. But this is like a set of notes that I've compiled over the last few years of references, explanations, sources, arguments, counter arguments for like a lot of the things that flat earthers seem to like to bring up. Now, if you want access to these notes, they are not free, unfortunately. Or fortunately for me, any level member of Patreon will get access to these notes. That's all of the notes that I use. Any member or any level of member on YouTube will also get access to these notes. So if you want these notes, if you want to debate flat earthers and you want to know what the not the talking points, if you will, but like what the relevant sources are, this has all of the scientific papers and stuff like this. That's probably what you should do. There's also a whole bunch of stuff about, you know, pyramids, not a lot about pyramids, some stuff about the moon landing, climate change, and all of this stuff. So, you know, I may as well shill for myself while we don't have any flat earth debaters right now. But yeah, it's a nice resource that, you know, I've assembled over the last few years. For other topics as well. Anyway, we have a guest. Let's bring up a guest. Rice Pudding, how's it going?
Good.
Great. What shape of the Earth do you think? What shape do you think the Earth is? All right. Why so?
How come shoes are flat? if the Earth is round.
Get out of here, rice pudding. By the way, the lowest level of Patreon is $5, so it's like $5 a month for any of them. I think one of the YouTube memberships is $4 a month because I said it wrong and you can't change it. I don't remember which one is $4 a month, but one of them is. So if you want a deal, it's 2025 and this is really a piece of discussion. Yeah, unfortunately, that is the case. That is the world we live in. Germs sending 5 Dr. Blitz Debunks gift memberships. So there are the 2 YouTube channels. There's Blitz PhD and then there's Dr. Blitz Debunks. Both of those memberships get you the same access to the same debate notes. And Germs just sent 5 gift memberships. So 5 people just got access. Was that a real, wait a minute. Was that an actual question or was he trolling? It was a troll. Also, shoes are curved. Like they are curved a little bit, right? You only need planet positions to debunk flat Earth. That's not quite right because they'll just say that the planets are just lights in the sky and we don't know anything about them. How do we use one of these gift memberships? If you've been gifted a membership, it's just automatically active. Now, it will go away after a month. So you'd have to renew it if you wanted to, but yeah, it's just 1 month free. It's just automatically active. You can just go to the YouTube channel that you have the membership for. There should be like a tab that says memberships and then you'll get the link. All right, let's talk to Son of Man. What a name. Son of Man, how's it going?
Hey, thank you. It's going great. How about you?
I'm doing all right. What shape do you think the Earth is?
I think it doesn't matter.
You think it doesn't matter what shape the Earth is?
Yeah.
But like, wouldn't it matter for navigating?
I mean, I'm not navigating.
Well, no, I mean, but like, but you agree that it matters at least to like some people.
I mean,
like it's
sure,
important to know.
Sagittarius A also matters to some people, I guess.
Okay, so then why'd you join if you don't want to talk about the topic?
Because the flat Earth conspiracy is well poisoning, you know. It's just to stir shit up, you know.
Okay, well, thanks for being here. Let's talk to the one. Oh, I guess you do have to activate a gifted membership. I've never been gifted a membership, so I don't know. The one, how's it going?
Hey, how's it going?
It's going all right. What shape do you think the Earth is?
I think it's flat.
Tell me about it. Why?
Well, to get to space, everyone's has only gone up. They've never gone, if it's a sphere of the world or not a flat, they've never gone down to space or traveled to the side of the sphere. They've always gone only up to get to space.
How would they, so down means towards the middle on a sphere, right?
You go to technically it's possible, but we don't have technology. You can go, if you were to dig straight down.
Yeah, but why would you do that when you could just go up?
True, it's just to prove the Earth is flat, not a sphere.
How does that prove the Earth is flat?
There's no sphere, it's just a flat surface, and you can either go up to space or dig all the way down to get
Do you think that space is real?
I've personally never been there, but something above the atmosphere, probably.
The atmosphere what?
When you see the stars, I know they're not close, so yeah, technically, yeah.
Sorry, what was it? The atmosphere what?
There's more than the atmosphere, basically. So yeah, there's
the atmosphere.
Definitely, yeah, the sky.
Sorry, what shape? What shape is the air?
No, the atmosphere, this spherical. That's what makes everyone think it's not flat. It's because the space.
Okay. Okay. Good troll. Good troll. Yeah, it's called the atmos plane, obviously. I've actually, or I've heard some flat earthers call it the Atmos. Brandomino, how's it going?
Yo, what up, buddy?
What shape do you think the Earth is? Thanks.
I think the Earth is a inverted Mobius strip.
I'm gonna start banning people. So the one has been blocked. What was the name of the guy who just joined? I'm just gonna start blocking people. Grand Domino has been blocked. People are just like, people are just gonna get banned at this point. Like it's like the trolls are annoying. Dust sent 1,000 joules. Thank you for the 1,000 joules. Let's talk to Jennifer. Jennifer, how's it going?
Hi, good. I'm so sorry I'm not opposition, but I did have a question.
Opposition only, though. It does say that. FLERF does bring out the trolls. It's absolutely true. But usually there are quite a lot of flat earthers that exist, unfortunately. Oh, I know him.
Yo, Dr. Blitz.
Wait, are you actually a flat earther?
Yeah, bro. You don't remember me?
No, I thought that you were a theist. What do I call you?
I am a theist in a flat earth. Call me Dr. Blitz Jr., bro.
I'm gonna call you Stocks.
What do you mean, bro? Come on.
Because your username.
Okay, you can call me Dr. Blitz's dad, okay?
I'm not gonna call you that. Okay. Why do you think the Earth is flat?
Multiple reasons, bro.
All right, why? Give me one. Give me your best one.
I'll give you my best ever argument, and you're just gonna go like crazy, okay?
Yep, I'm gonna be a flat earther. I'm gonna be a flat earther in 10 minutes. Let's hear it.
Exactly. I'm gonna show how a physicist. Oh, I don't know how to fucking pronounce it, but yeah, that thing that I'm basically smart. You get what I mean? Okay, so.
Brilliant. Let's hear it.
So the Earth is flat because, right? You gotta think of it this way, okay? First of all, when I look at the moon, right? When I look at the moon, why is the moon going like horizontally down, right? That only correlates if it's flat. Let's be honest.
What I don't know what you mean by horizontally down.
Like, okay, when we look at it, right? It's not like going in circles, right? Like if it was truly round, it will only make sense if it's going in circles. But it's not.
What?
Yeah, bro. But exactly. You don't even you're so flabbergasted.
You're right. I am flabbergasted. I'm, if you will, I am dumbfounded. I have found dumbness.
Well, nah, that's false. That's false. You see how smart my argument is. You're like, I never thought of this. I'm a flat earth.
Yep, that's what happened. That's definitely what happened.
Come on, bro. You know it.
So the moon goes down, right?
Yes.
Okay, and you're saying that it shouldn't go down if the Earth was a sphere?
Yeah, basically.
Stocks, do I have to kick you?
No! What do you mean kick me, bro?
I'm gonna look. So, chat.
What's good?
The thing is, I've spoken with him before. I'm actually not sure if he's trolling.
Listen, you see, my arguments are elite, bro. You know it.
But I think that he is. I should probably ban him, to be honest. I should probably block him because he's like regularly. Like, he is a genuine theist, but he's, like, kind of annoying, generally. So, I should probably just block him. Let's see if he wants to beg in the comments. Winston, how's it going?
What's going on?
Not a whole lot. What shape do you think the Earth is?
Oh, it's flat.
All right, why do you think so?
Oh, there's multiple reasons it's flat. I mean, common sense tells you that, the laws of water are the laws of water, and
sure. So you said that there's multiple reasons. You said that there's multiple reasons. What would you say is like the strongest reason you have?
Other than biblically.
Yeah, because I don't believe the Bible.
Say that I've done experiments on shining light on flat surfaces versus spherical surfaces.
Mm-hmm.
And the water doesn't reflect light the same as it does on a flat surface.
Wait, so is your argument that like water doesn't reflect? How does this get us to the Earth is flat?
So if you did it, I did an experiment where I froze a balloon full of water, right? And then I seen this experiment and I was like, well, let me try it by myself. So then I filled up like a rectangle glass, like a baking pan, so to speak.
Sure.
And you shine a light at one end, and on the flat surface, there's a straight line in the reflection, as if you was to look out over the water or a lake or the ocean and see either the sun reflecting off the water in a straight line to your eye, or the moon doing the straight line to your eye. But if you shine that same light on a round surface, it just puts a spot of light on that surface. It doesn't reflect in a straight line back to your eye.
Yeah.
You just see a spot.
Question.
So if we're on a ball, then it was going to work the same thing. I live on water.
That's what you would think. So Winston.
Well, let me finish now. The biggest experiment that I did went by the Glober's laws of 8 inches per mile squared.
Hold on, we're not changing the topic. I want to talk about the water thing. Right? You brought up the water thing. Let's not gish gallop, right? So
yeah, but the only thing that I've noticed about you when you speak is you just read what NASA or books have told you, not what you've learned yourself.
The only notes that I have up are notes that I wrote.
You wrote.
I don't even have them up right now, though.
From stuff you've read off the internet or learned in school, though. You didn't go out and physically.
No. I mean, I've done plenty of experiments. I've probably done more experiments than you have. But anyway, Winston, let's talk about the water, the reflection thing, right? So
yeah, you can do it yourself and prove it to yourself.
Yeah. So what happens if you make the balloon bigger? Have you tried this?
Yeah, yeah.
What happens?
It's the same thing.
So I've seen this done. I haven't frozen it myself. I've seen it done by somebody else. And big balloons, they start to smear the light source. So a very small balloon.
Yeah, but it doesn't produce a straight line.
If the light source gets smeared out into an ellipse rather than a circle as the balloon gets bigger, then you would expect that as the balloon gets bigger and bigger still, it will get longer and longer. And as the balloon got so big, perhaps thousands of miles across, it would look like a straight line.
But I can make it happen on two surfaces the same size, right? I take a small round surface and a small flat surface, and it works on the flat surface and not the round surface.
Right. So the reason why it happens at all is because you have a. Sorry, did you say something?
No, I'm listening.
Okay, so the reason why it happens at all on a flat surface, regardless of the size, it'll happen on any flat surface of any size. The reason why it happens is because all of the light is bouncing back in the same direction. And so you basically just end up with a whole bunch of light rays coming in at some, let's say, I could even just draw you a diagram if you want, but essentially it's just because of the angle of reflection. Now, on a round surface, like a small round surface, like a balloon, like, yay big, the angle of reflection is different depending on where the light is striking the balloon. However, if the balloon is big enough, then the surface is so close to flat that it will behave in much the same way. There will be negligible deviation. Essentially, the difference between a flat surface and a round surface that's big enough will behave very similarly to a flat surface of any size. I could draw you a diagram if you want, but this is the same reason why a basketball looks round. A basketball looks round, but if you zoom in onto a basketball, it'll start to look flat again. It's
Correct.
the same reason.
If you zoom in, right? If you zoom in and get down to like,
in the
fractions of a millimeter from it, right? But that's not what we're talking about.
But it is the same thing, right? Because the relative difference in size. So you were looking at the behavior of light reflecting off of something that was the size of maybe a volleyball or something like this, right? Or maybe a little bit bigger.
Sure.
And you are much larger than that, presumably. But the Earth that you're standing on is 4,000 miles in radius, and you are, a short king, maybe 6'2", right? So the relative size does matter here.
Yeah. Well, I mean, you see it that way, but common sense tells me that's not true.
Common sense is what.
Common sense tells me that sphere.
Common sense is not a reliable source of truth.
Has a calculation, right? It has a circumference calculation and how much it drops. That it drops off if you were on the top of a ball or a top of that basketball or a sphere. The further you go one direction, it starts dropping off, right? And you're able to note that and go, okay, well, if I walk this far and it dropped this much, okay, then you can start doing the math and come from get a beginning point and an end point, and now you have a distance. So now you go, well, if I rode 20 miles over that surface, right, by your calculations, at 10 miles, there's going to be 66.6 feet of drop, right? Is that how it is? Or is it 600?
10 miles is less than 1 degree of curvature.
We're not talking about degrees. I'm asking about
That's
how far
that's
that
how you measure curvature. You don't measure it in angles. You don't measure it in feet.
But you just told me that the Earth has a 4,000 mile radius, right?
Yeah.
So you can break down 4,000 miles into feet, can't you?
Yeah, but that's a radius, not a
Well,
curvature.
then why are you saying that you can't?
Radius and curvature are not the same thing?
But you can still do a mathematical measurement to create that curvature.
So
you're contradicting yourself.
If you're talking about drop from a tangent, then you can refer to that in distance, like feet, not chaos, in feet, miles, whatever. But if you're talking about the amount of curvature, you're talking about it in terms of angles.
Okay, so let me explain this then. If I had a building 100 feet tall, and I'm standing beside it, and I walk 20 miles from it in a straight line, I'm gonna go over the Earth's curve about 160 feet or more. So when I look back after I get 20 miles and look back and go, wow, the Earth is curved, I just walked over the curvature and now that building is hidden behind that curve. But I live on the Gulf of Mexico, so I can go 30 miles offshore, pull up my binoculars, and I can see my water tower in my home community that's only 130
So are you just complaining
feet
that you
tall.
can see things that are too far away?
No, I'm complaining that you're saying it's a ball and
Yeah.
that building should be hidden behind the curvature.
Okay, so what was the math that you did for that? Because we can just pull up the advanced Earth curve calculator if you want.
Okay, do it.
Okay, so what's the right? So I pulled it up. So what's the two locations?
Well, my water tower is like 3 feet above sea level on land. I live on an island community.
So you're telling me it's not a tower?
It's a water tower, yeah.
But it's only 3 feet tall.
No, it's on. Are you kidding me? No, it's on land.
Tower?
135 feet.
Okay, so it's 135 feet. Great.
Yeah. So it's about 3 feet above sea level right now on land, right?
So the
go
top
ahead
is
and add that
138
other
feet.
3
Sure.
feet.
And let's say
All
you're
right, so
short
now
at
it's
say
within-
6'2" or 6'2" or so. And how
Right.
how
So now
far
let's
away
get in
are
my
you
boat.
looking at it? Yeah.
Now we're getting in my boat and we're going 20 miles away. 20 miles offshore. We're going to go 20 miles out in the open sea. Right?
Sure.
And we're going to turn around and we're going to look at it and you're going to see the sun reflecting. You're going to see the sun reflecting off of something. And then you're going to pull your binoculars up and go, oh, that's my water tower right there. That's how I get home.
Do you have
every
any
single time
pictures
I
with
take
you
my boat out.
geolocated there?
What's that?
Do you have any pictures of that with you geolocated to 20 miles away from it?
Dude, you can do it by yourself. You can just walk out of your.
I don't know where you live.
Any city that you want and look
I've
at
done
different
this.
directions.
I've done this, and my
you see-
observations agree with
Okay.
what I would expect given a globe Earth.
So at 20 miles, how far should that be hidden?
Well, it depends on what
How
you're
far
looking at,
should
of
it be
course.
hidden? It's 8 inches per square mile.
At 20
But yeah,
20
you can
miles.
come. You can come. I invite you.
So
I
at
invite
20
you.
miles with with standard refraction, it should be hidden 140 feet. So I would just like to see the actual.
There you go. Shouldn't even be able to see it then, huh?
Well, yeah. So
But I can see.
I'm sorry. No, I lied. It shouldn't be hidden by. Oh no, I'm sorry. I'm adjusting the wrong thing. How tall's your boat, by the way?
My boat. I have a Carolina skiff, and it's got about 3 foot sides, and the floor is even with the water.
Okay.
So if you're standing in the boat,
if you were like 7 feet above sea level, you should be able to see the top of the thing.
I'm 6 feet tall, so I'm six. My
Short
eyes
kings
are 6
unite.
feet above sea level. Hell,
Okay,
I can stand up and see it. I can lay down and see it. Sit down and see it.
Well, I don't think that you would be able to see it.
I
if you
can
could
jump
sit
off
down.
the boat,
So
swim in
we
the
can.
water, and still see it.
given the right conditions, you should be able to see the top. This is 20.
I see the whole thing.
Oh,
I see the whole thing, and
I
the
kinda doubt
trees.
that.
I see the
You're
trees
telling me that you can
below
see
it.
the bottom of it?
I see the trees in front of it, blocking my view from the bottom of it. But I see the
Okay,
trees right.
and you can see the bottom of the
meeting
trees?
the
Because I
water.
kind of don't believe that.
What do you mean, dude? I'm inviting you here.
You're
I'll
gonna pay
invite
for
you
my plane
here.
ticket?
I'll pay your trip. I'll
Okay.
pay your trip.
Where are we
and then,
going?
And then let's me and you build a TikTok together. And
Absolutely. You'll
prove
convert
that
me to a flat earther.
I'll convert you to a flat earther.
All right.
And then
Yep.
you can shut down this negative devilish shit that you speak.
So wait a minute. So you say you're in Carolina, you said?
Florida.
Florida. And which direction are you? So what? I mean, you're inviting me to your place. So you may as well tell me where it is. So
Absolutely.
where is it?
I'm on the Gulf Coast. Of
Okay,
Florida.
but like where on the Gulf Coast? Which water tower are we talking about here?
A small town called Crystal River, Florida.
Crystal River. All right. Crystal River, Florida. Here we go.
Yep, and if the weather's real good, I could probably take you 30 miles offshore
That's
and
weird.
show you the thing.
Crystal River is not on the ocean.
It is too.
No, it's not.
It's a hint of the name, dude. Crystal River. And
Yeah,
how about
it's on a
Homosassa?
river. It's not on an
Homosassa
ocean.
is right beside it. Do what?
It's not on the ocean. Homosassa is also not on
My
the ocean.
house
It's on a
is on-
river.
The city is. I live on the Gulf, though. I live on the water. The city is built on the edge of the Gulf of Mexico, dude. It's right there. I mean, there's a Crystal River.
Just so everybody can see.
It pours out into...
This is Crystal River here. Here's the
Yeah.
Gulf of Mexico over here, yeah?
Yeah.
So where do you
And
live?
Highway 19 there is the closest
Uh-huh.
highway to civilization, basically.
Is this Highway
And
19
if you
here?
go to the... Yeah.
Okay,
Now,
so where do you live?
I live 5 miles towards the Gulf.
So along highway, so this is a map. Where do you live?
Yeah, you see there where it says like Homosassa Wild. You see there should be a little community called Ozello. You see it right there between Crystal River and Homosassa.
Yep, I see Ozello.
Ozello. You see there?
Yep.
It should say like St. Martin's River or something like that. That
Yep,
little
I see
bitty
that.
community there.
Is this?
That's
I can't
where I
even
live.
tell. Where does the ocean start?
But right there, the ocean. That's all flatlands.
Well,
That's all
flatlands, is
islands
it?
and flatlands.
Okay, so
Yeah,
so
but it's
so
still
where,
it's
so
still
where's so you
water.
go out in your boat. Where do you go from?
Yeah. I'm sorry.
So you go out in your boat. Where do you leave from?
From my front porch.
Right. But like, can you show me where?
What do you mean? Like,
well, like if you're,
you
are
gotta
you
find-
are you in
so you gotta
Ozello?
find. Yeah, I'm in Ozello. You gotta find.
So where?
Salt. You gotta find Salt River, Saint Martin's.
Actually, what can you locate? Can you tell me where on this map your water tower is?
Well, I can't move it. You have to go down a road called Ozello Trail.
Okay, so is this?
Find Ozello. Okay, is that Ozello Trail? Keep
I
going.
don't know. This is Ozello.
Well, okay, keep going. No, zoom back in.
Okay.
All right, go to your
This way?
left. Wait.
Is it this
back up?
Right here?
Right there. That's it.
Okay,
See the
great.
tower?
Great, we have the location. Let's put a pin there. Cool. Now, where do you go?
Go south. Go south of that. And you see that water?
Yeah, right here.
You follow that water out. What's that say right there? What does that
Paradise
say?
Island.
Okay, that's the river that I would take out. You're gonna have to go left.
Okay.
Left, follow that river out to the open water.
Mm-hmm.
And
Tell me
from
when to
that
stop.
tower to the open water is 3 miles.
So, like,
Now
is
you're
the
in-
open
there
water
you go.
here?
Now you're in open water.
All right.
Yep.
So we're saying like it's 3 miles from here to here.
No, 3 miles from that. No. Pull that pin up.
Okay.
Remove that pin.
Yep, it's gone.
Okay, now zoom in. Go out there where the islands and the water meet.
Yeah.
To the left.
To the left.
Go further out.
Further
Yep,
out.
Go further out.
Further out.
Yep, and you start seeing little islands right by themselves.
These guys?
Look for one that's called Bird Island or Bird Key.
I could probably just type that in. Bird
It's
Key.
right there in front of.
Oh, there we go. Yeah, Bird
It's
Keys.
right-
Here we go.
Okay, so that is 3.5 miles, and the Gulf
Put a
is
little
right
marker there.
behind you, wide open to Texas or Mexico, wherever you want to go.
Sure. Okay. So where do you go?
That's like the last island. And
So where
that's
do you
3.5
go?
miles
Oh, wait, where did
that should be around 3 or 3.5 miles to that tower.
Where did Ozello go? Oh, where'd the Ozello water fountain go? Water tower.
I don't know. You put a pin on it.
I did,
Thought
and I
you-
lost it.
Okay, go. It's on after the curb. No, you've gone too far. Back to the community.
Ah, here it is.
Right there. Yep.
Okay, so this is the key.
Mm-hmm.
And then we're gonna add a pin here. This is the water tower. Cool.
Yep.
Okay, we have 2 pins. So, and then you go where?
I go out to the Gulf. What do you mean? I go 20 miles
Okay,
straight
so-
out offshore, west, dead
So
west.
you just, and like your GPS tracking yourself?
Yeah, on my GPS, so I can go find my fishing spots.
Yeah, okay, so you go dead west from there. So you're telling me that you go from that you can see from here all the way to the water tower, 36 kilometers away.
Absolutely.
And you're telling me that you
Absolutely.
can see the trees even.
Absolutely. And I tell you what, if you
Really?
come here,
Can you see this building?
If you come here and go 20 miles offshore,
Can you see this building here?
and you can't see it, I'll pay you $1,000.
Can you see this building here?
What building?
This building that I'm
No,
looking
that
at right
building's
here.
below that building's below the trees.
Okay.
I mean, I can see it. Yeah, that's the old firehouse.
Can you see the church tower?
Not from the water,
Why not?
because it's a single story high.
It has a tower on top. I can see it here.
Oh.
It has a little thing
You
on
can't-
top.
That's a church. That's a single story church, dude. Okay, so what is it going to be? 30 feet high? I mean, I don't understand what you're questioning.
Oh, it is. That is tiny. Let's actually.
Yeah,
You
it's
know what
just
we
a
could
little,
do?
just a little house.
You know what we could
The
do?
firehouse
We
doesn't
can
sit
even
no
place
higher than the
ourselves.
trees.
We can even place ourselves probably where you want to be. So let's just go to the key. Actually, let's just place ourselves down in the key, if we
Mhm.
can. No street view available. Okay, let's place ourselves. Let's just place ourselves like over here in this dock. Probably a street view here. God, this place is in the middle of nowhere, isn't it? There's no
Yes.
street view anywhere. Look, so the only way that you could verify this for me is having a geolocated location and a photo. Do you have a photo?
A photo of what are you
Of
asking
the water
for?
tower. Yeah. Of the water tower.
Oh, you can't street view it?
No.
It wouldn't let you?
Unfortunately. There's no street view available. It's too
You
far in
pulled
the
up
middle
a
of
street
nowhere.
view of the church.
Yeah, that's because that's in a town.
Oh
no, I'm
it's
saying
just
a
right
photo.
beside the
I'm
church.
saying a photo of the water tower from like the middle of the ocean.
No, I haven't taken a picture of the water tower from the middle of the ocean.
So it sounds
looks
like
like a dot. I would need like a.
So how do you know that?
A cell phone wouldn't capture it. I don't think.
Cell phones are pretty good zoom these days.
It's 20 miles. It's 20 miles, dude. A regular camera just doesn't. I mean, I can probably. If I take, I mean, to get people in a picture, right? Like 10 people in a cell phone picture, you got to go like 20 feet back from them just to get all 10 people in it. And if they go in the back of the yard and try
Hold
to
on,
take
I'm
the
sorry.
same picture,
You said it's
wouldn't even
you said it's a
understand.
dot.
I'm sorry?
You said it's a dot? How do you know that you can see the bottom then?
I didn't say you could see the bottom. I said that I would be able to see the bottom of it if the trees.
How do you know that there's trees blocking you?
Because you pass them in the boat. 3 miles of them. You
No,
pass
I mean,
3 miles.
how do you
of
know
them in
it's
a
the?
boat.
How do you know that? That's a good point. I should get the elevation of the land. How do you know that you're getting the that you're seeing the trees? Because you said it's just a little dot, right?
Well, because you can look out, right? Like you can look over the water, see the reflection of the sky turning the water blue, and then you notice dark green, and then you see a white bubble.
You have that high resolution, but the water tower is just a dot. The water tower is huge
It's
compared
white,
to these
dude.
trees.
It's white. It's
The water
the further
tower is
you go,
huge
it becomes a
compared
dot.
to these trees,
In
and
fact,
yet, right? The water tower is pretty big.
See, listen, man. The whole point of this is I offered to take you and show you this,
Okay,
and if
you're
I'm
gonna-
wrong, if you can't see it, I'll give you $1,000. However, if you can't, then
Yeah, okay,
then you have
so-
to then
so
you have to
you're
jump
gonna
on
DM
my
me, right?
side.
You're gonna DM me and be
admit
like,
that you
hey,
were
I'm
wrong.
going to arrange. You're gonna DM me, right?
Absolutely, if you'd like me to.
Okay, yeah, DM me afterwards. Get me a ticket. Well,
I
I'll
know the
go to
Earth is
Florida.
flat. I
I'll
see
go
it
to
for
Florida.
myself.
So look, the issue is that you're making a claim that you can't verify except by flying somebody out to Florida.
It's
You
not
haven't
a
taken
claim.
pictures of this.
I'm-
It is, I mean, of course it's a claim. That's what, of course it is.
Well, I'm not the only one that can see it.
So that doesn't make it not a claim, right?
Okay, I mean, I guess it's a claim to you. I mean, it's 100% factual to me.
Claims can be true. Claims can be false. It being a claim doesn't make it
well, they
false
can-
or
they
doesn't
can-
make it true. It's just a
yeah, they
claim.
can-
But you're saying something, and I just have to take your word on it. But if I, on
Yeah,
the
yeah,
other
yeah.
hand, if I tell you that I have seen things be obstructed by the horizon before, like I've seen mountains peek out from behind the horizon top first. Well,
Sure,
now
I
it seems
too.
like
That's-
right. But
You're right.
but if that's the case, now it seems like we have two conflicting claims, because that doesn't work on a flat Earth.
What doesn't work on a flat Earth?
Mountains peeking out from behind the horizon top first.
Okay, then let's look at it this way. If you're driving down a road, right, in the summer, or at least here in Florida, roads are long and flat.
Mm-hmm.
At the vanishing point of that road in the horizon, or way off in the distance in front of your car as you're driving down the road, you get these heat vapors that cross the road, look like snakes sliding
Yeah.
across the road.
I'm familiar.
Okay,
I'm familiar.
you know there's not 100 snakes crossing the road, right? You would
That's
catch
called
up
a
to one
mirage,
of them
yeah.
at some
It's called a
point.
mirage.
Okay, it's because of the atmosphere at that particular moment. So so our eyes' perception,
You're
the
right.
way we see that, it's are different things. But when that process isn't there, right? If that atmospheric problem isn't there and it's crystal clear, you don't see those things, right? If it's hot
We're
out,
talking
you
about
see 'em.
mountains. By the way, just
Correct,
and just to
correct.
clarify, just to put a bow on this. So if you were even say 19.5 miles out, you would be able to see it on a globe Earth even without any abnormal refraction. So like being able to see the top of the water tower is actually somewhat plausible if you're off by a mile or so, or if there's particularly strong refraction or whatever. So like this is not like impossible. But anyway, how does seeing the top of a mountain make sense? How does seeing the top of a mountain first make sense on a flat Earth? Because that happens every time, not just sometimes, but every time.
Is away. That depends on how far it is away. Really.
So a
You know,
mountain
like
is
if you
a
look-
mountain is behind the horizon. And then as you drive closer, the mountain peaks up top first, and then you see more and more of it as you get closer and closer.
No, I mean, where are you looking at mountains? So you would have to have your eye.
I live in Arizona, so like I'm surrounded by
above.
mountains.
Right. So, but to actually, like, so if you're standing on the ground and you're looking at a mountain, if you're in the woods, then you're looking through trees, right?
I live
So
in
now if
Arizona.
you-
There are no woods.
Oh, really?
Yeah,
Arizona.
it's a desert.
Right.
It's just dirt for miles. I mean, once you get out of the city, it's dirt for miles anyway.
Well, maybe that's why you're a glober, because you don't live on somewhere that's flat, right? So nothing else makes sense to you. You just think that,
what?
Oh, I see this first. That means it must be the horizon.
Well, no, but I mean, like, look, this is a thing that you could check for yourself too. Just go to somewhere where there are tall mountains. Like, I don't know. You could go to like Chicago or whatever. And not Chicago. Denver, Colorado is what I meant. And what you'll see is as you drive closer and closer to the Rockies, you'll see the Rockies will peak out. I mean, the Rockies you can see from very, very far away, but you'll see them peak out from behind the horizon. And then as you get closer, they'll get higher and higher. How does that make sense? This happens anywhere that there are mountains.
I've seen the Rockies.
Yeah, so
I've been there. I've seen the Rockies.
How is it?
Drove all through.
So how is it that the Rockies peak out from behind the horizon as you get closer and
They
closer?
don't. They don't. For me, they just come into view. You know, I remember traveling across Montana.
Do you see the top of the mountain first or the bottom of the mountain first?
No, I don't think I've ever seen the top first and went, "What is that? There's something pointy over there." What
it
could
just
that
looks like
be?
a tiny mountain.
I just kind of see the whole outline.
Ignore that. Sorry, go ahead.
I just notice a whole entire outline of something that coming into my view, and then I go, oh shit, that's the mountains. You know, they're finally coming into my view.
Hold on,
That's
let me see if
all
I
I
can find
see.
something
I
for
don't
you.
see. I don't see that. I don't see the peak of the mountain at eye level, and then it starts rising in the air as I get closer to it.
What
I
part
just
of the
see
mountain
off
do you,
in the
do you-
distance.
so do you think that you see the whole mountain first? The whole mountain at once? Or do you think
No,
you
you
see
can't ever see anything whole at first because there's always something blocking your view, right?
well,
There's
you
a
can see
tree
do
or
you
a
think that you see
plant or
95% of the mountain?
I don't
all at
know. It
once?
depends on the situation. Am I coming around a curve and see something, or am I, on a flat plain in Kansas and I'm, coming up to the very first mountain known to man after you cross Kansas? I don't know what your situation you're in. You'd have to make your own,
Have
create
you
your own
ever seen
situation.
the bottom half of a mountain before you've seen the top half of a mountain?
I don't know how to answer that. I've seen one side of a mountain before I've seen the other side.
Yeah, I'm talking about the top half versus the bottom half.
I mean, if I see the bottom, I'm pretty sure I can see the top unless it's too high and it goes up into the clouds.
Right. Do you think that if you can see the top, that means that you see the bottom?
If you can see the top, can you see? It depends on where the mountain is compared to where you're at.
If it's far away.
For the
Let's say that you can see the
your
top. Does
eye's
that mean that
perception.
you can see the bottom?
No.
Why not?
Well, I'm looking out my window right now, right?
Mm-hmm.
And I can see the top of a tree.
I don't mean like the actual bottom. Let's say like halfway down, say.
I don't know how to answer you. I don't know how you're visually constructing this question.
So, have you ever seen mountains with snow on top?
Yeah.
Okay, so the snow doesn't go all the way down, right? Especially if
Right,
they're tall
'cause
mountains.
it's colder.
So
'Cause
you
it's
will
colder
see
the
this.
higher you get.
So if the mountain is far enough away, and you look at the mountain,
Mm-hmm.
you will only see the part with snow on it. As you get closer, you'll see the stuff below the snow.
So are you talking about like mountains like Mount Rainier or Crystal Mountain in Washington?
That would be a great example. In fact, actually,
so the Mount Rainier towers above the natural mountainous landscape there. I used to live in Seattle, by the way, so I used to I skied over on Mount Rainier. So if you're far away, so if you're on I-5 coming from Portland, Oregon, and you come over a certain hill and boom, you see the top of Mount Rainier sticking through the clouds, right? You can't see that. You can't see below the top.
Mount Rainier
right
might not
there.
be a great example because the clouds are really low in that part of the world, right? So like the clouds might be blocking your view too, right?
Mm-hmm.
But this is a phenomenon that you can see the tops of the mountains before you can see the bottoms of the mountains, even in places
but you're
that
adding more.
that there's
You're
no
adding
clouds.
a more difficult. I think you're adding more difficult understanding of what you're trying to. The bottom line is, right.
The bottom line is that you can see. The bottom line is that you can see.
Whether you see.
The bottom line is that you can see the top of mountains before you see the bottom of mountains. Every time.
Okay, sometimes yeah, sometimes that might be so.
No, every time.
Well, if I was driving through a wooded lot, right? If I was right into some
Assuming
woods,
nothing is blocking your view.
and then I come around a curve and there's an opening.
Assuming
and right
nothing
in
is
front of
blocking
that
your
opening,
view.
Yes, and I come around a curve and boom, there's a wide open spot. And there's something blocking my view off in the distance. It's the bottom of a mountain. Now, as I come out of those trees, I can start looking up and see the top of the mountain now.
Assuming that nothing is blocking your view, will you see the bottom of
I'm
the mountain
saying
before the top of the
I
mountain?
said you're driving through a wooded section of the mountains, right? Or you're riding through a road going to the mountains. Lots of trees all over to the left, lots of trees to the right, trees blocking the road
Why are
in
we
front
assuming
of you.
that there are trees blocking stuff? Imagine that there are no trees.
Because that's how nature is, dude.
There's not trees everywhere. There's not trees everywhere.
Okay.
There are places
I'm
that don't have
putting you
trees.
I'm putting you in a scenario.
You're accusing me of overcomplicating it, but you are the one adding trees.
Yeah, but you're the one saying that you can see the top of the mountain before you see the bottom of the mountain.
You can see the top pointy tip of a mountain before you see the bottom half of the mountain.
Because you're not close enough to the bottom? Or is there something blocking
because
your
the
view of
Earth
the bottom?
is curved, and the horizon, the curvature of the Earth blocks the
on
bottom
your
half.
curve, Okay, on your curved earth, on your mountains, does water go up the mountain and then down the other side, or does it?
Water
Does
goes
water
down
flow
mountains.
from
Water
does the
goes
water
from the
flow
top of the
from
mountains
top
down
of
to
the
the
mountain
bottom.
down to the bottom, and then when it gets to the bottom, where does that water go to?
Just
It
depends
obviously
on
forms itself into a river, right?
or a lake
And
or
then
whatever.
that river goes into a lake, and then where does that water go?
It depends. This seems irrelevant though.
But
You know that, you
it's
know that,
being held. It's
so
being
down is
held in
towards
by
the
the banks
center of the earth. Not
But
down is not like
to our
left.
to our molten core of our Earth of our sphere. But when you go swimming in the water, the further deep you go, the colder it gets.
Yeah, until it hits 4 degrees.
And our sun is 240
Winston,
million miles away.
Winston,
but
hold
yet
on.
it gets colder as
have
you
you
go
thought
up.
about these things? Have you like looked into them
Yeah,
as to
my
why?
whole
Okay,
life,
so
dude. I was just like you 5
do you
years
have
ago.
doubtful. Do you
Yeah,
know
had the same thoughts.
What answer do you think I will give for why the bottom of the ocean is colder than the top of the ocean?
You would probably say there's less light.
Right. And what's wrong with that explanation?
Less light.
What's wrong with that explanation?
Well, because if you go in the sky, right, if you take an airplane and go up and get closer to your sun, it should get hotter, shouldn't it?
No.
How do you say that? If it's 95 degrees on Earth, right, in Arizona.
Air is transparent. So
if you get
very nearly
if
transparent
I do-
anyway. So unlike water, water absorbs a lot of light. It absorbs a pretty big fraction of light. So by the time you get 100 feet down, there's basically no light. Hey, me too.
Correct.
So air, on the other hand, doesn't absorb the light. So it's not going to be hotter, and then it's going to get dark as you get closer down to the surface because the air up top absorbed the light. The light just passes through the air. So there's going to be no effect from the light on the temperature of the air, at least not a significant one. Because the actual relative distance between the surface of the Earth and the top of the atmosphere is negligible compared to the distance to the sun. So the distance to the sun is unrelated. Sorry?
They sure got you brainwashed, don't they, buddy?
That's a cool response to an explanation that you have no rebuttal to.
Well, I mean, I that is my rebuttal. It's not. It was my idea. You rebutted and said I was wrong.
You asked a question. I gave an answer.
No, you asked a question to me, and then you rebutted why I was wrong.
Did you not ask why is it that it's not hotter the higher you get in the air, even though you're closer to the sun?
The question you asked, what do I think your answer would be?
Yep.
For you saying
and it was
that
a great
the water
response
gets
for the
colder.
ocean. Great response because the water absorbs the light. The light is the source of the heat here, right?
Yeah, but it doesn't matter. You can go into a 5 foot swimming area that has a natural spring coming out of the middle of the earth from the.
Well, it's not coming out of the middle, but yeah, there are things called geothermal vents. Yeah.
Yeah, you can go dig a simple hole in dirt out in your backyard and notice that it gets colder the further you dig.
Until you get to a certain depth. So actually, interestingly enough, as you go more than a mile or 2 miles or 3 miles down into the crust, it actually does get really hot.
It does.
Yeah,
because we've dug 7 miles,
and it got so hot that they couldn't. That's why the Russian borehole stopped, because it was getting too hot and the rocks were getting mushy.
No, they did it because they couldn't get through it.
They couldn't get through it because the rocks were getting mushy. That's how hot it was.
No. That's not what it says. They quit digging because they didn't have a strong enough tool to dig any further. It got so hard.
Let me find you something.
Just destroyed anything that they tried to do.
It's not great.
But anyway, the $1,000 still stands. I'll message you somehow.
Oops, that's the
on here.
wrong browser. 1 sec.
No.
We're not done. Hold on. You're not running away just yet. Here, this is the Russian borehole. Then it was the turn of the Kola super deep borehole. Drilling was stopped in 1992 when the temperature reached 180 degrees Celsius, 356 degrees Fahrenheit. This was twice what was expected at that depth, and drilling deeper was no longer possible because the temperature was 180 degrees Celsius.
And what does that translate to Fahrenheit? What is that?
356 degrees Fahrenheit.
Okay, so solid tar turns to liquid and will flash at
liquid.
500.
It's not liquid. It's just
Solid
gummy.
tar will turn
go
to
ahead.
liquid at we use solid tar on our everyday world.
Sure.
And we use it at a 500 temperature. At 525 it flashes, right? But we're still putting our steel tools and mixing it in a steel environment, but they had to stop because theirs got 400 degrees. Big fucking deal.
So,
that's not going to stop. That's
so
not
look,
going to stop a
Winston,
drill
the
bit.
issue is that it got so hot that the rocks became gummy. You can't drill through gummy rocks.
Well, then they should have been able to scoop it out, right?
How are you going to scoop out of a 7-mile deep hole?
Well, I don't know. You're the one that claiming that it gets hotter. You tell me.
That's what they say was the reason they stopped.
Said. That's
the
right.
people who
and
are
you
digging
are
the
a
hole.
Believer.
The people
You
who
are
are
a
digging the
believer
hole
in
said
what
that.
they say.
The people who were digging the hole said that. Where are you getting
Correct.
your information
They
from?
did. They did.
You're claiming that they stopped because they couldn't keep drilling for some miraculous reason. Where are you getting
That's
that information?
right. Because the rock
only
got
information
too
we
hard.
have. Where's your evidence of that?
Well, I'm not on a computer. It's on I've seen it on the internet myself.
Okay, did you hear it from the people who were digging the hole?
No, did you? You just read that off of the internet.
I sourced it from them.
Okay, I mean, so what? You're still getting it from
I'm getting
another
it from
source.
the
You're
people who were digging the hole.
You're in such denial, dude. And that's okay because I'm going to get you where I'm going to get you.
Look, you're just making
where
it
you
up.
need
It
to
seems
be.
like.
I'm not. You're. I'm making it up. Okay, look. So the
I
offer
don't know
still
where
stands,
did you
dude.
where did you hear that the rock was too hard that they couldn't keep digging? Where did you get that information?
Just over debates over the years. I don't know. It's came up 2 or 3 times. I don't know.
Okay, so
it
you
goes
don't
in
have a,
one
you
ear
don't
and
have a
out the
source?
other. Just like
One ear.
I don't have a source. I got you on my phone in my
But
hand.
like you don't remember off the top of your head, like roughly where it came from, because that's like kind of
No,
important information.
I've been dealing with this. I've been dealing with this conflict issue for about 8 years now.
And you still don't.
It was talked about then.
You still didn't understand the whole business about mountains.
What do you mean about mountains?
Like how mountains, you can see them peak first, and then.
I don't know. I don't
apart.
know how you see mountains. I know how I see mountains. I know when I see a mountain, I go, "Oh shit! There's a mountain. There it is. There comes the mountains. We're almost to the mountains, sweetheart. Let's drive through the mountains now."
So,
but that doesn't have anything to do with around the world. I mean, you think that we live you think that we live on a globe flying through
One sec.
space?
Let me see if I can find you a cool picture of something. That's probably a winter picture. I'm looking for a picture. I'm looking for a picture of Mount Fuji from the distance, because Mount Fuji is like a really impressive mountain, and it also stands alone very much so. I can't find any good pictures.
Right, it's a volcano, right?
Here's a pretty good one.
Isn't that one a volcano?
Yeah. So I'm trying to find you a good example of like a mountain that you can see the snow-covered cap from, but you can't see the bottom bit on. But unfortunately, Mount Fuji it's often cloudy and foggy, so Mount Fuji is probably a bad example of those kinds of photos. I'm sure that we could go find something if you wanted. But look, all you have to do is just...
Somebody said a question, why are my theories better than our facts? I don't know who that was, but...
It was just a commenter. Look, so...
I thought it was kind of funny.
So there's a question that you should ask yourself, which is, like, if you give me some unexplained fact, I can almost certainly offer you an explanation, right? Do you think that I probably could?
I don't want you to. I don't want any. I got on here specifically to make you a deal, to make you an offer, And if you want to go find this out for yourself with me, and I can show you what I tried to explain to you that you're telling me that I can't, that it can't be true. I mean, hell, you'll get a free fishing trip out of it, and maybe $1,000.
So look, and like we can talk about that afterwards. We can arrange it or whatever. What I'm asking is, do you think that there are things that a globe Earth cannot explain that a flat Earth can?
Yeah.
Okay.
Wait. Say that again. That
a globe Earth
cannot
explain that a flat Earth can.
Yeah, it can explain the laws of water.
What are the laws of water?
So the laws of water, right? If you try to manipulate water in any way, it always, you could pour it on whatever you want to pour it on, and it'll bond to itself until it consumes, right? Whatever it's on,
what
right?
Law of water is this?
Even if you poured water in a bowl, right? And we fill this bowl all the way up to the top. Now we're getting really close to the top, and you start adding a little bit more water. If you look at it, that water will bond to itself and create like a curvature.
You're talking
right?
about surface tension, yeah.
Okay, surface tension. Now, if I touch that water and slide my hand over the edge of that, that water will follow that little stream that I did with my finger and empty itself back to where it has to bond, bond to itself.
So
okay, now
what's the issue with the globe Earth here?
So that water is going to go over the edge of that, right, and keep going until it finds a container that can hold it, till it can hold itself, right?
And sorry, what law of water is this?
What do you mean, what law of water?
Is there like a name for this law? Can I find this in textbooks, like in physics textbooks that, they would teach it to high school students or whatever?
Okay.
Because I've never heard of a law of water. I've definitely heard of
I've never heard of
Have you heard
law
of
of gravity either. I've never heard of a law of gravity either.
But,
it's a theory.
It sounds like you just did. It sounds like you did hear about it because you called it what it is.
Yeah, well, I've heard that term to laws of water too. I mean, there's the laws of the land, right? There's
if I Google law of water, what do you think I'll find?
Yeah, do it. See what it says. I've never Googled it. It has a purpose, right?
The law of water.
It's going to do what it does, just like a tree. There's a law.
So I just Googled law of water. So the AI overview, we can skip the AI overview if you want. It's probably not super reliable, but it's just talking about legal stuff with regards to like marine laws, There's also something called Pascal's law. Maybe that's what you're referring to?
I don't know. Is Pascal some guy that tried to put his name in the books like Einstein did?
Pascal's law is a particular law about fluids, in particular relating the pressures of fluids with gravity
that they
and
do
velocity.
things with?
And anyway, so it's like stuff about fluid pressures. But everything else is like, the law of laws like legal laws, water rights, commerce and legal systems explained.
You're breaking this down for what? You're breaking this down for what?
It sounds like the law of water is not a real thing. It sounds like it's not a real thing.
But you completely understand what I'm meaning and what I'm asking and what I'm saying to you.
So how does the surface tension that's present in water, how does that disprove the Earth? Or rather, what can the Earth not explain?
I mean, I don't understand how you can't figure this out. If the Earth is a globe, then there's always going to be curvature. Right, yep. So if I'm on top of the globe on its flattest surface, and I let in the water, I pour water at my feet. Okay, if I'm on the very dead top center, right, it's going to start curving from my feet to my left, to my right, forward, backwards, and all angles from that point. Correct?
It'll do that wherever you are on Earth.
Okay,
on the globe Earth. Right.
Okay, but I'm just using the very highest.
It'll spread out.
Right.
The highest spot is like Mount Everest, by the way.
So in your outlook on the Earth, in 8 miles, in 1 mile, the Earth drops 8 inches.
Yep.
So
tangent from a curve.
I know that if I went
drop from a tangent. I'm sorry.
If I went to a lake, right? If I go to a lake here in Florida, and let's just call it a 1 mile across lake, It's square.
Mhm.
Let's call it a square lake.
Yep,
1
square
mile,
lake,
one
1
direction.
mile, 1 mile across. Sure.
1 mile, right. So now I'm going to go dig an 8-inch trench 2 feet from the shoreline. And I'm going to dig that trench about, let's say 50 yards. I'm going to dig an 8-inch deep trench.
Yep.
50 yards.
8-inch
And then
deep
when I
trench,
get that
50
50
yards.
yards
Do you
done,
mean
when I get
50
that-
yards like parallel to the shoreline or like away from the shoreline?
Yeah, just away from it. Just away
Okay.
from it. Dig a trench. Now
Sure.
I've left 2 feet. I've left 2
Yep.
feet of space. Now I'm going to go take out that 2 feet, 8
Mhm.
inches deep. And now I've taken 8 inches of surface water out. As soon as I take that 8 inches, that 2 foot of that 8-inch, all the water that's above 8 inches is going to flow out of
Yeah.
that trench.
Yeah.
But you say it doesn't work for the oceans and the
That
world?
would work for the oceans. It's just the oceans there's not enough space anywhere for the oceans to drain, right?
To drain.
That's what you're talking about. You're talking about draining like the top
Because
8 inches of a
gravity is
lake,
holding
right?
this ball? Because
No, because
gravity
the
is
oceans are
holding
enormous.
What?
Like where would you put the water if you were to try to
You
drain it
tell me.
away?
It's going in a curve. Obviously, it would fall to the
so
very
the example
bottom. It would
the
fall
example
to
that you've given, is like you're draining a lake of the top 8 inches of the water, right?
If I displace 8 inches, yes, on a level surface.
So the Earth is too big. The ocean is too big to drain the top 8 inches of the ocean. Where would you put that water? Where would it go?
You can't drain it, dude. But if it was on a ball, it would all go to the bottom. It would all go to the bottom.
That's not what you think, is it?
Fall off.
Why would it? You know the bottom is south, not down, right?
That's why I referenced I'm going to be on the top, so you would have
the
no
Earth doesn't
questions
have a
to ask.
top. It has a north. It has a north and it has a south. The globe doesn't have
hold
a
on.
top.
It has a north pole and a
Yeah.
south pole, according to your
the
model.
North Pole's not the
and
top.
The North Pole is the center.
It's not the center.
And it's on its axis 23.4 degrees, correct?
23.5 degrees, but yeah.
Okay, well, whatever. But it also fluctuates, 2 to 3 degrees throughout the year?
No.
That's why they get to turn the wobbling space ball?
No, it doesn't fluctuate.
So
It fluctuates over
take out
tens of
that-
thousands of years. But look, it seems like
you
you're
like to argue,
confused.
man.
It seems like you're confused about like the top versus the north. The
Is it?
North
Am
Pole
I?
is not the top.
And-
The North Pole is not the top of the globe.
Okay, well let me say it how you can understand it then. So
Please.
let's take a basketball in your hand. Set it on the floor at your feet.
Yeah.
Now bend over and put your finger right on the top of the ball.
Yeah.
Now
sure.
does that make sense? Now
Sure.
pour
Yep.
water down your finger and see if it stays on the surface of that ball.
Yeah.
At the
I mean,
same
some
exact
of it
surface.
will. Some of it will.
At
but
the
most of it
same
won't.
exact surface.
So
at
Winston,
the same exact surface.
Winston,
that
some of it
gravity
will.
works.
Winston,
and
some of
holds-
it. Winston. Some of it will.
Some of it will.
Oh my
Yes,
God!
water
Can you
will
let me answer?
stick.
Okay, I have to mute you. I'm sorry. Some of it will stick to the basketball, but most of it will not because the Earth's gravity is pulling it away. The Earth's gravity is pulling the water towards the Earth. It's gripping it towards the surface. So having water at the North Pole, it won't fall down. Gravity is not towards the South Pole. Gravity is towards the center. So it's going to pull it equally in all directions. You can unmute now.
Sorry, man. I think my mic got turned off.
Yep, whoops. I don't know how that happened. Wild.
I don't know.
But did you hear my answer? Did you hear my explanation?
No, I think I was asking. Did you mean the center of like where the
Center
Earth's
of the
core?
Earth. Yeah, the Earth. Gravity pulls you towards the Earth's core. It doesn't pull you towards the south. It doesn't pull you towards the South Pole. It pulls you towards the Earth's core.
Interesting.
I don't know. You've said you've been doing this for 8 years and you don't know that?
Dude, I don't know. I don't see that's how that's working because water.
If you're trying to debunk a model, you better know what that model is.
Water will come out of the mountains, right? In streams, at springs out of the mountains. form into creeks and streams. Streams turn into rivers. Rivers turn into big lakes and reservoirs, which usually drain into an ocean of some sort, whether it be a sea or an ocean or a gulf.
Yeah. And did you know that the banded armadillo is the only armadillo in the United States?
The banded armadillo?
Yeah.
I don't know. I got armadillos in Florida. They're different. They're different out in Texas. I don't know what they're called though.
Did you know that one of the largest temple complexes in the world is in Cambodia?
Temple complexes? I mean, they're everywhere too, right? They're in New York, they're in Europe, they're in France, they're everywhere. That's from the old school civilization that was here before the the reset and the collapse of fucking that's a whole other story.
Yeah. Isn't that a cool fact? I mean, you were telling me a cool fact, so I figured I would tell you a cool fact.
What the armadillo thing?
No, the temple complex thing. I actually think the armadillo thing's not true.
I
was just kind of BSing you, but the temple complex thing is definitely a true fact.
But yeah, I'm interested in. I'm in awe over the cathedral.
I mean, it
were used for.
It sounded like we were just telling each other cool facts and not talking about the shape of the Earth.
Right. Well, man, I think I've spent enough time here with you. I appreciate you taking me on, but like I said, I'll hit you up somehow.
Okay.
Send you a message, and we will connect. And $1,000 in it for you if you can prove me wrong.
Okay.
All right.
Thanks for being here.
Have a great
Winston.
day.
Take care.
Yeah.
Oh, honestly, that felt like a waste of time. I'm probably not even going to upload that one because it was like, I was bored. I think that you guys would be bored too. No, it was rough. I probably won't even upload it. It was like an hour of trying to get him to understand how mountains work. And like, he's a Florida boy. Like, I get it. Like, you don't see a lot of mountains when you're in Florida. I get it. But look, y'all, it is the end of the live stream. It is noon. I need to go drink some coffee. Yeah, I have a feeling that I would not come. Yeah, somebody said you won't be getting off that boat. Yeah, I wouldn't really feel safe about that, to be honest. So anyway, I will see you guys on Sunday for the Unapologetic Show. Make sure that you join the Discord if you're 18 plus. If you're 18 years or older, make sure to join the Discord server. You can get announcements from me. You can get video and video announcements, live announcements from me. You can ask me questions. You can ask each other questions. Whole bunch of great things to do in the Discord. And yeah, consider becoming a Patreon. That's how you get becoming a Patreon is how you can get access to my debate notes. You can also get access by becoming a member on YouTube, on either of the 2 YouTube channels. Anyway, y'all, I will see you guys on Sunday. Take care until then.